So guys, please acknowledge whether my voice is audible or not. Please acknowledge once whether my voice is audible or not. Please write down in the comment section my voice is audible or not, so that I can start. Please. Can anyone among you acknowledge? Am I audible? Please write down in the comment. I can see students are there. Please write down in the chat box. Am I audible or not? Hello. Okay, audible. Thanks, cool bro. So guys, see, in this session we are going to discuss some probable questions related to ISRO. And in ISRO there are questions which are, some are very lengthy and some are very straightforward. So what I have tried, I have collected some set of questions as a practice or mock test. It include all category of the question, very basic question also, and some complex calculative question also, and some smart and tricky question also. So the purpose is here so that you can get aware, okay, this kind of question can be asked in the exam and we need to make our mind frame in such a way. And second thing I see, when you're going for the ISRO exam, as calculators are not allowed, right? So basically you need to remember few things, like what is the log 2 value, what is the log 3 value. If you know these values, then you will be in position to solve most of the question. So what I will be doing here, I will be sharing with you people question and giving you some minute to solve the question. And if you believe you have solved the answer, you can put down there in the comment section, and then later I will be sharing the solution with you people. Okay, so you can see on the screen, my screen, the first question is, consider the system shown in the figure, and if the damping ratio of the system is 0.60, it's not 0.6.0, it's 0.60, then the value of k, you can see k is here. You can see on my screen, this one is the k value, right? Okay, this one is the k, what is being asked in the question. So guys, tell me, if the damping ratio of this system is 0.6, then what will be the value of k? To sustain the damping ratio at 0.6, what should be the value of k? Please tell me the answer. Comment answer in the comment section, please. Go ahead guys. Question is in your screen. Consider the system shown below in the figure. If the damping ratio of the system is 0.6, then the value of k is, tell me the answer please. So guys, tell me the answer please in the comment section. I request you all, tell me the answer in the comment section. I hope my question is visible to all of you. Please comment down answer in the comment section. Guys, please comment answer in the comment section. Question is in front of you, and please like the session if you find this useful and convenient. Please go ahead. So what we will try to solve this question, and we will try to answer this question in the time frame, that is the 90-minute, okay, actual exam time frame. So tell me the answer. What will be answer for this question, guys? Please come up. So this is a second order control system, and if the damping ratio is given, he's asking you the value of k. I'm not getting any answer from your side. Please guys, answer in the comment section. What should be answer? Yes, Mr. Cool bro, there are so many students watching this. Please share your answer. So guys, whenever you have this kind of question, what you need to do, you need to reduce this and compare with the standard second order prototype control system, right? There is a standard transfer function, that is omega n square upon s square plus twice of zeta omega n s plus omega n square, where zeta is your damping ratio and omega n is your natural frequency. That is the hint I'm providing you people. So this question is framed in such a way, first minimize this section, right? Then you can cascade this section transfer function with this. Then obviously whatever value of transfer function you are getting, you can compare that with the standard. So from there you will get the answer. Okay, so the answer for this question is, guys, you can see here, solution is this one. C is the correct answer. What I did, I basically minimize the transfer function, and then after minimizing the transfer function, I found this value, forward path just, okay, and the forward path is omega n square upon s into s plus twice zeta omega n, and comparing these value, I got omega n square 25, so omega n 5, and 25 plus k, I got twice of zeta omega n. You can see this one can be compared with this one. So putting this value, putting the value of zeta, putting the value of omega n, I got value 6, right? So putting this equation, 25k plus 1 is equal to 6, I am getting the value of k is equal to 0.2. So what will be the correct answer? Answer was C. So guys, please comment your answer there in the comment section. So answer for this question was, I'm writing again, answer for this question was C. You can see that is 0.20. So this was a very straightforward question, and this kind of question you can experience and you may expect in the ISRO exam. Moving forward to the next question, I have taken the mixed question. So guys, moving forward to the next question, this one is the question on your screen. So this is the question coming from the transmission line. I hope this question is visible. The question is, a 50 ohm distortion-less transmission line has capacitance of 15 nanofarad per meter. If the attenuation on the line is 1.2 into 10 raised to power minus 3 Napier per meter, then the resistance per unit length will be in milli ohm per meter. What should be value? आपको बताना है कि डिस्टॉर्शन लेस लाइन का रेजिस्टेंस क्या होगा पर यूनिट. इज इट क्लियर? इन मिली ओम पर मीटर में वैल्यू क्या होगा? टेक अ क्वेश्चन एंड टेल मी द आंसर. So guys, take 20 to 30 seconds. See, you have 80 to 100 question. Okay, so you need to solve them in well frame of the time, that is 90 minutes. So we don't have that much bandwidth, we don't have that much time. So try to solve each question in 30 seconds to 1 minute. See what will happen. All the 90 question or all the 80 question will not take equal time. Some might be very lengthy, some might be very tricky, some might be very short question. Okay, so on an average your timing must be 30 seconds to 1 minute. Tell me guys, what will be answer for this question? A distortion-less transmission line has a capacitance of 15 nanofarad per meter, right? If the attenuation on the line is 1.2 into 10 raised to power minus 3 Napier per meter, then the resistance per unit line will be in milli ohm per meter. You know, when we talk about the transmission line, we have the lossless transmission line, we have the distortionless transmission line. So there is condition for the distortionless transmission line that is defined in term of its physical constant, that is R, L, G and C. तो आपको वो डिस्टॉर्शनलेस कंडीशन याद रखना है. अगर आपको वो कंडीशन याद है और अगर आपको कैरेक्टरिस्टिक्स इंपेडेंस का रिलेशन याद है डिस्टॉर्शनलेस ट्रांसमिशन लाइन का, तो आप इजीली आंसर कर पाओगे. So guys, please comment down answer for this. A 50 ohm distortion less transmission line has a capacitance of 15 nanofarad per meter. If the attenuation on the line is 1.2 into 10 raised to minus 3 Napier per meter, then the resistance per unit will be. Tell me the answer, please, guys. Come up, please. Guys, please, whosoever is watching, there are a lot of people watching in the live session. Please comment your answer. I'm not getting your answer. Please come up. Share your answer. What answer you're getting? So guys, please comment your answer. What answer you're getting for this question? Solve it, please. Go ahead, go ahead. Tell me the answer for this. What will be answer? So guys, answer for this will be D. So you can see here, this one is the condition. You can take the solution. This one is the condition for the distortionless transmission line defined in term of its physical constant, right? And the characteristics impedance of the distortionless transmission can be defined like this way, and this value is given. So now he is asking for the attenuation. Is it clear? So attenuation is also given, I guess. Is it clear? Attenuation is given there. You can see here in the question, the values given are attenuation is given and characteristics impedance is given, capacitance is given, and he is asking you to find the resistance. So straight away you can use this relation, R is equal to attenuation into under root of L by C. I'm not going for the detailed derivation. I'm not going for the detailed derivation of these. I have taken the answer alongside. So this will be the answer. So the correct option will be 60 milli ohm per meter. So the answer for the second question will be, guys, I'm repeating again, answer for the second question, that is a 50 ohm distortionless transmission line which has a capacitance of 50 nanofarad per meter, and the attenuation was given and the resistance was asked. So I first calculated what is the condition for the distortionless transmission line. This is the condition and this is the characteristics impedance, and then I just put the value of all the constant given, and I end up getting this value. Attenuation constant is 60 milli ohm per meter. So now third question is on your screen. Please go ahead. This is basically question which is from the analog electronics. Guys, tell me what will be answer for this question. Come up, please. What is the answer for this question? Come up, please. Tell me guys, what will be answer for this question? So guys, I'm not getting answer from your side. Am I audible? Mr. Cool Bro, if you are there, am I audible? Please comment down your answer for this question. So guys, tell me what will be answer for this. This is the analog electronics question which is being asked here. So if I am audible to you, then please put your answer. All those students who are watching, please share your answer in the comment box. What will be answer for this question? The cut-in voltage for the each diode given in the circuit is shown 0.6, and it's given each diode current is 0.5 milliampere, and then the value of R1, R2 and R3 is respectively asked from you. It's a very straightforward question. You know, three values are given here: option A, option B, option C, option D. R1 value mentioned, R2 value mentioned, R3 value mentioned. So this one is the R1, this is the R2 and this is the R3. Tell me the answer. Guys, tell me the answer. Okay, fine, not an issue. Come up, please tell me the answer. Guys, take it as a rehearsal and a practice. Okay, so these kind of question you may expect in the final ISRO exam. So please come and post your answer. Only then I will be in position to judge how much you have prepared well for the exam. I've told you people, in ISRO there will be question from the mixed category. Some question will be very straightforward, some question will be conceptual, and some question may be lengthy in the calculation. So likewise, the same way I have structured this mock paper. So this is the time you need to rehearsal and practice. Please put down your answer. Come up, please. So a lot of students are watching, 11, 10, 15, 20 students are watching, but you are not putting your answer. Guys, tell me the answer. What will be answer for this? So in this question, you know, answer is A, 10 kilo ohm, 5 kilo ohm, 2.93 kilo ohm. Okay, if I go for the solution, you can see this will be the exact solution for this. What is being mentioned that each diode current is 0.5 milliampere. One diode was here, so current will be 0.5 milliampere. Obviously, one diode was here, so 0.5 coming from here, 0.5 from here, it will sum up 1 milliampere. And similarly, you can say one diode was here, 0.5 coming from here, so 1 plus 0.5, this current will be 1.5. You can see here, like this one, and I will go for the calculation. So guys, if you're asking this R1 value, what it will be? It will be this voltage minus this voltage divided by this current. So this voltage you can calculate, and this voltage will be 5 minus 0.6, that will be 4.4. So you can see 10 minus 0.6 minus 4.4 upon 0.5 milli, answer you are getting 10 kilo ohm. So if you're asking the R2 value will be this voltage minus this voltage divided by this current, right? So you know this value is 4.4 and this value will be minus of 0.6. So you will get 5 kilo ohm. Similarly, if somebody is asking you the R3 value will be equal to what? R3 value will be this voltage minus of this voltage divided by this current. So you will get this answer. So the answer will be 10 kilo ohm, 5 kilo ohm and 2.93 kilo ohm. So guys, tell me if there is any confusion in this. I'm repeating, the answer will be A option. What I did, each diode current was mentioned there and diode cut-in voltage was mentioned there. I just calculated the R1 value, R2 value, R3 value. And you know, resistance is simply potential difference between the terminal of the resistance divided by current flowing. So for this, I calculated the potential difference between this point and this point, that I calculated like this way, divide by current. Similarly, for I2, I did this minus this, divided by current. Similarly, for this, I did this minus this, divided by this current. Fine. I hope this point is very clear, right? So moving toward the next question. So guys, now this one is the next question. A small dipole of length 0.02 lambda is excited with the RMS current of 4 ampere. The power radiated by the antenna is. The power radiated by the antenna is. Tell me the answer. What will be answer for this? Again, this is a EMFT question. So all students whosoever are watching, please post your answer. This is very important question from the ISRO point of view. Let me give you people a hint. He is asking the power radiated. So this is the hint you might know. The power radiated can be written as, you know, I RMS square multiplied by the radiation resistance. I hope you got some hint from here. So RMS value of the current is given here. So it will turns out to be 4 square multiplied by the radiation resistance. These kind of question they may ask from the antenna part. So guys, please put there in the comment section your answer. What would be answer, right? So come up, please. Option A, option B, option C, option D. 4 options are there. Come up, please tell me the answer. Guys, tell me the answer. Take your time and tell me the answer, please. This is an antenna question. A small dipole of length 0.02 lambda is excited with a RMS current of 4 ampere. The power radiated by the antenna will be 4 options are being provided to you. Tell me the answer, please. The hint I already gave you, people. The power radiated will be I RMS square into radiation resistance. So the only thing you must know that is how to calculate the radiation resistance for this length of the antenna. So guys, so answer will be D. Answer is 5.05 watt. So how you calculate? You can see the solution here. So this I told you people already. First you need to calculate the radiation resistance, right? And you know the radiation resistance can be calculated by this for the given length of the antenna, and then the RMS value of the current was given to you, and you know power is equal to I square into R. Since we are talking about the radiated power, so it will be I RMS square into radiation resistance. So you first calculate the radiation resistance and then you can go for the power radiated. That is coming around near 5.08 something. The closest best option is 5.05 watt. So this will be a solution for this question. Please go ahead, check it. So guys, that's what I'm telling. I have taken your question, which is basically mix or amalgamation of the some easy question, some tricky question, and some lengthy question, so that you may expect these kind of the same question on the final exam. So you can rehearsal well how to solve these kind of question, right? So I'm telling you time and again, don't only think that they will ask you very straightforward question. If they're going to do like this, that will be well for all the students. Cutoff will go high. But there may be few challenging questions, so you need to mentally prepare yourself also for those challenging questions. So I'm repeating, the student who are joining in between, this was the question asked. A small dipole of length 0.02 lambda is excited with the RMS current of 4 ampere. The power radiated by the antenna is 4 options were given in the watt, and we know power is V square upon R, either I square into R. And when we are calculating the power because of some AC effect, the cause is AC, alternating current, oscillating charge particle to radiate the electromagnetic wave. So there we need to consider the RMS value of the current and voltage. And the RMS value of the current was given as a 4 ampere, and I need R. R will be radiated resistance. So that we know we have the standard formula for any length of the antenna. So that will be 80 pi square dl upon lambda ka square. You put the dl whatever is given in the question and calculate the radiation resistance, right? So moving toward the next question. Thank you, sir, please.
Okay, so this is a question from digital electronics. Multiplexer, all of you know. सॉल्व करो जल्दी से, और फाइनल आउटपुट एफ क्या होगा इसका, ये आपको बताना, राइट? व्हाट इज द फाइनल आउटपुट एफ ऑफ दिस सर्किट? सो मल्टीप्लेक्सर इज इंपॉर्टेंट and you may get one question from multiplexer in your exam. There is a possibility, so you should know how to solve. Anyone who getting the answer, write your answer in the chat box. So in multiplexer, you should know the output expression of 2x1 multiplexer, 4x1 multiplexer, 8x1 multiplexer. Okay, you should know. So here, first of all, we need to compute the output of this first multiplexer. Okay. So what is this? In this multiplexer, output Y will be equal to what? Y equal to this S naught, which is B. Okay, so we can directly write B also here. Okay, in place of S naught, you can write B also. So S naught bar we have, so B bar, and then I naught, so it is 1 into 1. Okay, or plus S naught, that is B, into I1, that is 0. So equal to B bar. This is the output expression here. Okay, Y equal to. right? So B bar we can write here. Anyone who got the answer? AB whole bar. So AB whole bar is what? So now come to this F equal to. So this F equal to A bar, this A bar, okay, here, because S node bar. So A bar into I node is 1, or plus S node, that is A, or into this I1, that is B bar. So it is A bar plus AB bar. Now using the distributive property, you can write it as A bar plus A, or into A bar plus B bar. So this is 1. A bar plus A is 1. So A bar plus B bar. Okay. So this is the answer, A bar plus B bar. And here this option is also actually equal to this one. Okay. So we can change this. Here it is A bar, suppose. Okay. This is the problem. So B option we can take in exam. Clear to everyone? Now come to the next problem.
So guys, next question, C of the diode circuit. Sandeep, actually it's not C. You once again check, it will be A. I have also provided you the solution. Okay. So right now what we will do, we will stick to the question live on the screen. This is the question on the screen. Again, this is from the EMFT. Okay. Anirudh, Sandeep, all people, please comment on your answer, right? Okay. So you can see the question written is a line of characteristics impedance Z0 terminates with a load of ZL, load impedance equal to Z0 by 4. Then the reflection coefficient of the line is, you have the 4 option, please go ahead. You have the 4 option, please go ahead. There is one person, Mr. Cool Bro, 0.2 is not answer. Yes, Mr. Anirudh, A is the right answer. That's what I told you people in the beginning. I have taken the question in such a way, few questions are very straightforward and few questions are tricky and few are very lengthy. Because in ISRO, you will find the same pattern. Some questions are very straightforward. Okay, Anirudh, your answer is perfectly right, minus 0.6. So guys, I'm giving you a small hint. You know, when there is a impedance mismatching, then there will be reflection in the transmission line. Okay, as it's being taught in the question or given in the question, a line of characteristics impedance Z not terminates with a load, means load is not equal to the characteristics impedance. It is some fraction of the characteristics impedance. So it's obvious there will be reflection coefficient, and you people know reflection coefficient maximum value is 1, minimum is 0, right? In magnitude I'm talking about. Okay, yes, research odyssey, answer A will be right. So you might know this will be the standard solution. You can check it, please. So reflection coefficient is calculated ZL minus Z0 upon ZL plus Z0. It's in fact plus Z0. Okay, it's in fact plus Z0, right? So you put the value, you will be getting the answer minus 3 by 5, which is minus 0.6. So cool bro, the answer will be minus 0.6, not 0.2. You can see all the options were given in the negative. And I told you people, if he asked about the maximum value of the reflection coefficient, in magnitude it can be 1 and 0 it can be least value. Okay, so this is a very straightforward question. So moving ahead with the next question, guys, tell me the answer. See, I have taken the second question. That question was something like here. Is it clear? Do it fast, please. Tell me the answer. Again, a distortionless line operating at, you can see the question given is distortionless line operating at 60 megahertz as the following parameter G, L, C. The resistance per unit length in kilo ohm per meter is, you know, when we talk about the transmission line, there are 4 physical constants which model the electrical behavior of the any transmission line, be it coaxial, be it two wire line, be it parallel wire line. Is it clear or not, right? So they are the conductance, they are the inductance, they are the resistance, they are the capacitance. Out of those 4 physical constants which are used to model the electrical behavior of any transmission line, in this question 3 are given. C is given, G is given, L is given. The 4th one missing is R, that is being asked, right? So I've told you people 101% you may expect one question from the distortionless transmission line. Either it's related to calculation of the characteristics impedance, either it's related to the calculation of the attenuation constant, either it's related to calculate any of the physical constant out of R, L, G and C. One question I take earlier and one question is this one, right? So answer, many people are putting D. Yes, other people come up please. What will be the answer? Tell me please, what will be the answer? Yes, other people tell me what will be answer, please. Go ahead. Tell me the answer. 25K. No. Mr. Anirudh, answer is 25K. D. So guys, this will be the answer. I told you people the condition for the distortion less is R by L is equal to G by C. This was given to you, this was given to you, this was given to you, this value is to be asked. So you may calculate, I guess D option is coming, right? So 2.5 kilo ohm per meter will be the perfect answer. So guys, there might be small calculation mistake. Please ignore that. But I'm telling you the concepts here, how you can solve the question, right? Can we go ahead? Now, next question. You have this question. Please take a question. Guys, tell me the answer for this. This is a question from the EDC electronics devices and circuit. The question given is a P plus N junction at 0 biased, means nothing applied externally, at T is equal to 300 degree Kelvin, has a dopant concentration, acceptor dopant concentration 10 raised to power 17 per centimeter cube, donor is 2 into 10 raised to power 14 centimeter cube. Then the Fermi level in N side above the intrinsic Fermi level is how much electron volt, and some constant values are given, Ni value given and thermal voltage value given, right? So guys, let me tell you one thing. I have told you in the beginning also, please remember the value of the log 2, remember the value of the log 3, because that will be very helpful in solving the ISRO question. Please tell me the answer for this. Read the question and tell me the answer. What will be answer for this? Please come up. Come up, please. What will be the answer for this? Guys, tell me the answer. What will be answer? Yes, come up, people. Research, Mr. Iksh Nagarjun, please tell me the answer. What will be answer? Come up, please. You people know that when we talk about the doped semiconductor, then there will be a difference in the Fermi level position with respect to the intrinsic. In N-type semiconductor, Fermi level lies above the mid of the Fermi band, right? Or intrinsic Fermi level, or that depend upon the doping concentration. What is the level of doping? You may think like this way. And in acceptor, it goes beyond or below the intrinsic or above the valency band. So he is asking the same thing here, the Fermi level in the N side above the intrinsic Fermi level. So if I take this one as an intrinsic, this one as a EFI intrinsic, and this one as a position of the N-type Fermi level. So he's asking this difference. What will be this difference in the electron volt? So people come up and tell me the answer. What will be this difference in the electron volt he's asking? And these constant value you need to use intrinsic carrier concentration and thermal voltage. These are the 4 options. Tell me answer, please. Come up, please. Come up, please. Tell me, guys. So guys, the answer will be A. Reason I have told you people, this one is the standard solution for this. He is asking on the N side, and this is the difference in the Fermi level of the N side with respect to intrinsic. Vt, natural log of the Nd upon Ni. Nd is the donor concentration and Ni is the intrinsic carrier concentration, which was given in the question. So if you put the value of donor here, intrinsic carrier concentration here, then you will get the difference 0.247 electron volt. Please check on your screen. So guys, I've told you the question asked was if we have the doped P and N type junction and it's at the zero bias at T is equal to 300 degree Kelvin room temperature, and the dopant concentration for the donor and acceptor was given to you, and for the reference thermal voltage was given to you, and if not given we consider that as a 26 millivolt, and intrinsic carrier concentration is standard 1.5 into 10 raised to 10, also that was given to you. On the basis of that, he was asking if we are using the that much doping for the N side, what will be the difference in the Fermi level of N type with respect to intrinsic. So you might have studied that there is a difference. This is the standard formula. Similarly, we have the formula for the difference in the Fermi level of acceptor to the intrinsic. That will be Vt natural log of Na upon Ni. And if we add these two difference, ultimately we will get the difference between the Fermi level of N and P, that is ultimately the contact potential, and from there we make the new formula, that is the contact potential or built-in potential, right? Clear? Yes, Ayush. Question will be definitely PSU exam time. I agree to you, but see, you can't say that all the question will be of the PSU's exam type. Since this is a mock test, so we are trying to convey you people most of the type question, be it a straightforward question, be it a tricky question, be it a lengthy calculative question. You need to practice all kind of question, because if the paper is easy, cutoff will go very low and it will be easier for all the people, right? So be prepared for all the question. So answer will be A, that is 0.247 electron volt. Next question is this one. Now, consider the circuit shown below in the figure. The RC value, this value is 1 kilo ohm. The value of the collector current is given this one, and the value of the VT is 25 millivolt. If the value of the collector current, DC collector current is 1 milliampere, then what will be the voltage gain? So Ayush, I agreed to you. There are 95 questions, 120 minutes. That totally I agreed with you. But I am telling you time and again, these kind of questions you may expect, because these are the very straightforward questions. See what happened when you are solving these kind of the question in the gate. There are the multiple kind of the complexity or kind of the conceptual term the examiner usually make. But in the ISRO, he's giving the straightforward question, right? So what will be answer for this question? I'm repeating the question again. This is the given transistor, and given the value of the collector current expression is given here. The thermal voltage is given here. If the value of the collector current is 1 milliampere, then what will be the value of the voltage gain, right? So now I'm giving you people one hint here. This is the common emitter configuration. You all agreed to me, right? Again, when I teach analog electronics, I ask always student to remember the standard formula. What is the voltage gain for the common emitter without RE? What is the voltage gain for the common emitter with RE? What is the voltage gain for a common base? What is the voltage gain for common collector? Yes, agreed to you people. AV voltage gain will be minus GMRC. I agree to you people. So RC is given here exactly. So what you will say? The AV will be equal to minus GM into 1 kilo ohm. So guys, again the question is how you will calculate the transconductance. Tell me the transconductance. Again the question is to calculate the transconductance, right? So there is a very small, a very quick trick examiner has played. Can you tell me the quick answer? What will be A, B, C, D? Which will be the answer? Please tell me. Come up, come up. What will be the answer? Please tell me. Guys, tell me what will be answer. Please come up, come up. Yes, Hemant, answer is minus 20. Agreed. Answer is minus 20. Agreed. The other people? Ayush, again, you are committing a mistake. That's what I told you. There may be a small trick. You are giving the transconductance IC by VT. So let me correct you. That transconductance is when IC is equal to ISE raised to power VBE upon VT. That is the small trick examiner played here. You can see he had mentioned it twice of VT. Is it clear? That's what I'm telling you people. The questions are mixed. They are very straightforward question. They are tricky question and they are lengthy question also. So if you don't know anything for a moment, but you still remember transconductance is nothing else del IC upon del VBE. Is it clear? You all agreed or not? So if you don't remember the formula, just do the partial differentiation of this with respect to VBE. So what you will be getting GM. So GM you will be getting equal to IC upon twice of VT. You all agreed or not? So most of the student will be using the transconductance IC upon VT, but here you need to use IC upon twice of VT. I hope Ayush, my point is clear. Still confusion? Anirudh, your answer B is again wrong. Answer will be A. Please check. Come on, guys, please. Ayush, Anirudh, please tell me. Any confusion? Arey bhaiya, you can see here na the value of the collector current IC is equal to ISE raised to power VB upon twice of VT. Most of the time we all have the habit, or we always remember the formula I, diode current, is equal to I naught E raised to power VD upon eta VT. Eta is the utility factor. Okay, it may vary, it can be 1, it can be 2. So examiner played the same trick. He remember, he knows, most of the student remember, cram the formula transconductance is equal to IC upon VT. But this time he changed the physics equations. He changed the physics equation of the transistor current. There he put the 2 in the denominator. So you can't use IC upon VT. You need to go IC upon 2 VT. How? I've given the calculation here. Simply do the derivation of this. You will also get IC upon 2 VT, right? So I hope I have made my point very clear. So you can see the answer, and I have put the detailed solution for this also here. You can take a screenshot for this. This is on the screen, please. So guys, why I have taken a solution? Because I don't want you people this session to extend beyond 2 hours, 3 hours. Okay, that will be wastage of time for you also. What I will do, I will explain the concept here, and for your for your assistance, I have taken the solution. What I told, how I calculated voltage gain for the common emitter without emitter resistance minus GMRC. Remember the formula, nothing worries, right? And RC is given. Now to calculate the transconductance, I'm using the standard formula. I calculate the transconductance, put the value, answer will be minus 20. Agreed or not? So guys, I hope it's clear, right? So this type of question I have mixed in between. Few are the tricky, few are the lengthy, few are the very straightforward. And the same structure you will be expecting in the final exam. So moving ahead toward the next question. Thank you, sir, please.
Okay, so in your exam, you may expect 2 or 3 questions from mathematics also. Those may be from matrix, those may be from differential equation, maybe from probability, okay, and maybe from calculus, right? So this question is from differential equation. You have to solve this differential equation, okay? So right now I'm giving you some time to you. Just try to solve. How will you solve this differential equation? dy upon dx plus y ln y equal to 0, okay? If y0 equal to e, then y1 is equal to what? Just try to solve, and what answer you are getting, write your answer in the chat box, okay? So what will you do here to solve this? Okay, Anirudh is getting C answer. Very good, Anirudh, very good. Well done. So what we can do here, if anyone want to understand it, I am giving you the hint. You can write dy upon dx equal to minus y ln y. Okay, then you can write dy upon y ln y equal to minus dx. Okay, and now you can see this is variable separable form. Okay, so you can integrate both sides to solve this. Okay, so let us put integration symbol here as well as here. Now this integration can be done using ln y equal to t. Okay, so यहाँ पे ln y equal to t substitution use करेंगे. So 1 upon y dy कितना हो जाएगा आपका dt. Okay, so integration dt upon t or equal to this is minus x or plus c. Now this integration, all of you know 1 upon t का integration ln t होता है, right? So we can write ln t equal to minus x plus c. Okay, now t is equal to ln y. So ln of ln y equal to minus of x plus c. So this is the general solution of the differential equation. Now by putting the boundary condition, this at x equal to 0, y is equal to e. Okay, this is y0 equal to e means at x equal to 0, y equal to e. Okay, so if we put this x equal to 0 and y equal to e, so ln e is 1 and ln 1 is 0. So this becomes 0. So c is 0. It means this constant is 0. So finally we are getting ln of ln y is equal to minus of x. Now they're asking value of y at x equal to 1. Okay, so if we put x equal to 1, then what will be the value? So ln of ln y is equal to -1 at x equal to 1. Okay, and we know that ln y is ln is -1 when this input is what? 1 upon e. Okay, because ln e is 1 and ln 1 upon e is -1. So y is equal to what? E to the power 1 upon e. Okay, so C will be the right answer to this question. So differential equation से क्वेश्चन आपको मिल सकता है, मैट्रिक्स से मिल सकता है एग्जाम में, and some basic question from probability also, right? I hope clear to everyone. अनिरुद्ध का आंसर ठीक है. Next, let us move to the next question now. So this is from digital electronics. Okay, so you just read the question and try to find out the right answer. Okay, so from counter, from register, there may be some question in which you need to calculate the state diagram. Okay, you know, in digital electronics, there you will get questions from digital electronics. Some question will be very easy, which can be solved in 5 or 10 seconds, and some question like from counter or register, there may be some question which can take some time to calculate the state diagram. Okay, so let us compute and tell me the final answer. What answer you are going to give in your exam? So this question may take more than 1 minute. Okay, but that time will be compensated by other questions which will be very easy. Okay, which will come like in 5 seconds, 2 seconds, 10 seconds you can solve. Okay, so now let me tell you the procedure. Okay, you can solve it yourself then. You know, ये डिवाइड बाई 5 काउंटर है, मतलब मोड 5 काउंटर. डिवाइड बाई 5 का मतलब क्या होता है? मोड 5. ओके, सो मोड 5 काउंटर है या मोड 7 या मोड 8, वी हैव टू कैलकुलेट द मॉडुलस ऑफ दिस काउंटर. या फिर दूसरा ऑप्शन हो सकता है कि दैट इट इज नॉट ए काउंटर, इट इज ए शिफ्ट रजिस्टर. शिफ्ट रजिस्टर हैज नो स्पेसिफिक सीक्वेंस ऑफ स्टेट्स. सो ये भी पॉसिबिलिटी है कि शिफ्ट रजिस्टर तो नहीं बन रहा है, राइट? यही हमें चेक करना है कि इसका अगर ये काउंटर है तो क्या मॉडुलस है या फिर ये शिफ्ट रजिस्टर है. सो वी नीड टू कैलकुलेट द स्टेट डायग्राम ऑफ दिस. ओके, सो अगर इरेगुलर सीक्वेंस आपको मिल रहा है देन डी आंसर होना चाहिए. ठीक है, डज नॉट फंक्शन एज ए काउंटर ड्यू टू डिसजॉइंट साइकिल्स ऑफ स्टेट्स. और अगर एक वैलिड स्टेट डायग्राम बन रहा है, आपका पार्टिकुलर सीक्वेंस बन रही है, देन इट इज काउंटर. ओके, जितना भी इसका मोड आएगा. सो हाउ वी कैन कंप्यूट इट? लेट अस राइट डाउन. मैं आपको हिंट दे रहा हूं, आपको खुद सोल्व करना है. ठीक है, पूरा सोल्व नहीं करूंगा मैं. सो देखो, Q0, Q1, Q2 ये एक सिंक्रोनस काउंटर है बिकॉज ऑल द क्लॉक इनपुट्स आर कनेक्टेड टुगेदर. सो इट इज ए सिंक्रोनियस सर्किट. काउंटर या रजिस्टर जो भी है सिंक्रोनियस है, राइट? अब यहां पे हमने लिखा पहले प्रेजेंट स्टेट, वी विल राइट दैट इज Q0. ठीक है, Q1 एंड Q2, दिस इज द प्रेजेंट वी आर राइटिंग. देन वी विल राइट द इनपुट. सो यहां पे इनपुट क्या है इस वाले फ्लिप फ्लॉप में? डी इनपुट इक्वल टू Q1 एक्सनोर Q2. ओके, नोर. ओके, ये नोर गेट यहां पे लगा हुआ है ना. सो वी विल राइट डी नॉट इक्वल टू Q1 प्लस Q2 होल बार. ये नोर गेट यहां पे लगा हुआ है, राइट? एंड देन दिस इनपुट इज D1 इक्वल टू Q0. ओके, इक्वल टू Q0. एंड देन D2 वी कैन कॉल इट एज D2 विच इज इक्वल टू Q1. इक्वल टू Q1. क्लियर टू ऑल? नाउ नेक्स्ट स्टेट यहां पे जो आएगा उसको मैं यहीं पे आगे लिख दूंगा. ठीक है ना, नेक्स्ट स्टेट जो आएगा वो मैं यहीं पे आगे लिख सकता हूं क्योंकि प्रेजेंट नेक्स्ट स्टेट बिकम्स द प्रेजेंट स्टेट. So suppose initially it is in 0 0 0 state. इसको हमने 0 0 0 स्टेट में ले लिया स्टार्टिंग में, राइट? दिस इज द initial state, suppose, right? So what will be the denote input? Q1 plus Q2 whole complement. Okay, so Q1 plus Q2, 0 plus 0, 0 का complement 1, and ये कितना है आपका 0 और ये कितना है 0. So this is the input combination. Now in D flip flop we know that output follows the input. So what will be the next state of this? 1 0 0. जो input है वही output हो जाएगा. So next state will go to 1 0 0. Okay, 1 0 0, right? So we can draw here 1 0 0 state. Clear to everyone? Now again we will write the input combination. So D naught equal to what? Q1 plus Q2, okay, whole complement. So 0 plus 0, 0 का complement 1, and ये 1 यहाँ पे और ये 0 इधर. So now inputs are 1 1 0. So clock जब pulse आएगा यहाँ पे, ठीक है, positive H. So next state will be what? जो inputs हैं वो output पे जाएंगे. So 1 1 0. So यहाँ पे आएगा 1 1 0, right? 1 1 0. This will be the next state. And now we take 1 1 0 as the present state. And again we write the input. So 1 plus 0, 1, its complement will be 0, and this one here, this one here. So next state is coming to be 0 1 1. Okay, so let us write 0 1 1. This is the state. Now this becomes the present state now, 0 1 1. Okay, now again D naught equal to what? 1 plus 1, 1 complement 0, then this 0 and then 1. So now we are getting 0 0 1. So 0 0 1 after this. Okay, 0 0 1. And again we will write this 0 0 1 as the present state now. Okay, 0 0 1 comes here, present state. Okay, now this Q1 plus Q2. Okay, so 0 plus 1, 1 complement is 0, then this 0, then 0. So now again we are getting 0 0 0 state. So we are getting a particular sequence here. Okay, एक closed cycle बन रही है, mode 5, ठीक है, 1 2 3 4 5. So we can call it as a divide by 5 counter. एक valid state diagram यहाँ पे बन गया. Okay, now you can try to calculate the other states also. ठीक है, जो बाकी remaining states हैं उनके बाद क्या situation बनेगी ये भी आप compute कर सकते हो. Okay, so this is the procedure. Now let us move to the next question.
So guys, next question is on your screen. I hope this is the question from the network. Please check it and tell me the answer. So see guys, I am telling you people to solve it as early as possible. Reason being, as Ayush or somebody was telling, there is very less time and huge number of questions. Okay, so this is question from the network. For the network shown below, the value of the RL that will receive the maximum power is. It means it's a question from the maximum power transfer theorem, right? And this is a purely DC circuit. So you people might have studied maximum power transfer theorem for the DC circuit, for the AC circuit also, right? So the very first thing is you need to think of the DC circuit only as of now, and it is consisting of the dependent sources and independent sources. Let me read the value if you people have confusion in visualizing the value. This is 10 volt, this is 6 ohm, this is I1 variable, this is dependent source 10 I1, this is RL. So for which we need to find the condition, or we need to find the value of RL so that it will receive the maximum power. This is 2 ohm, this is 8 volt, this is the 15 ampere current source upward, right? So these are the four options: 7 ohm, 3 ohm, 18 ohm, 20 ohm. Please do it fast in 20 to 25 seconds or 30 seconds. Or see, I told you people, on an average time must be 30 seconds to 1 minute for the question. Is it clear? Do it fast, please. Tell me the answer for this. Tell me the answer for this, please. Guys, come up, please comment the answer for this. This is a question from the network. What will be answer for this? I've told you people a hint also. See, when we talk about the maximum power transfer theorem, so power will be transferred maximum if the load resistance is equal to the internal resistance, or load resistance is equal to the Thevenin resistance, or Norton, what else you call, right? And any of the electrical circuit can be modeled as a source or as a load. As a source, we can either model in terms of the voltage source, either we can model in term of the current source. If we are modeling the entire equivalent complex circuit in term of the Norton, then we need to use the current source. If you're modeling in term of the voltage source, then we need to use the Thevenin, right? So that concept you need to use here. And people, please tell me the answer for this question. Come on, please tell me the answer for this. Four options are here. So now it is very clear. Let me give you one more hint, that you need to simply calculate here R Thevenin or R internal or R equivalent, right? Okay. So whatever value you will get by solving for the RTH, R equivalent, R internal, that will be your RL value, under which the maximum power will be transferred to the RL. I hope you all synchronize and comply with my statement. Okay. So now you might have studied in the network. There are three kind of the circuit basically. One circuit can be containing only independent sources. There it's very simple and straightforward method to calculate the R Thevenin or R internal. What we do, we simply remove all the independent sources. Second may be containing only the dependent sources. There what you do, you simply put one voltage source, 1 volt or 1 ampere current source, and find the voltage and current across its terminal. Resistance will be voltage upon current ratio. Third is, if it's containing dependent and independent both, there are two options. Either calculate VThevenin, I short circuit, calculate the ratio, that will be RTH, or either remove all the independent sources and make the circuit only the dependent sources and repeat the second iteration. Yes, Anirudh. Yes, Anirudh, answer is 18 ohm. Your answer is perfectly correct. Anirudh, your answer is perfectly correct. Answer is 18 ohm. Please, people, all people, suggest your answer also. Come up, please. Come up, please. Please, guys, tell your answer, please. Answer is 18 ohm. 18 ohm is perfect answer. So, guys, you can see this is the solution for this. I told you people what I'm doing. I removed all the independent sources, okay, and I made the circuit into the circuit containing only dependent sources. And if I have the entire circuit now containing only the dependent sources, the position where I need to calculate the R Thevenin at the position of RL, there I inserted 1 volt dummy voltage source. And I start calculating, because of this voltage source, how much current is flowing into entire circuit. So then my RTH will be that 1 divided by I ratio. And similarly, now you can see this is a simple circuit. You can apply a mesh or you can apply a KVL, right? And you can see I1 is coming in this direction, I is coming in this direction, I1 equal to minus I. So this entire KVL equation will be containing only two variables. One is I1, one is I. As I have modeled here, you can see the KVL equation. And since I need to calculate the ratio of 1 upon I, why? I am calculating the RTH, I am calculating the R internal, I am calculating the R equivalent, which is equal to voltage at that point divided by current flowing at that point. Voltage I assumed 1 volt, dummy voltage source. And because of that current flowing, I am assuming I. So 1 upon I will be my RTH, and I calculated like this, eliminate the variable by putting I1 is equal to minus I will get the answer 18 ohm. So guys, that's what I told you people. I have taken the solution here so that I may not have, end up wasting a lot of time here. So I believe you all got the answer. Yes, Aniruddha, your answer C was right. Yes, Hemant, your answer C is right. So guys, if there is any such kind of question, so solve them like this way. Okay. Now going for next question. Again, this is the EDC question, very simple and straightforward question. Tell me the answer, please. Guys, tell me the answer for this. Do it fast, please. The question is, an N-type silicon sample has a diffusion coefficient of the electron 120 centimeter square per second. Carrier lifetime of the electron is 30 picosecond. Then the diffusion length of the sample is. Yes, tell me. Tell me. Yes, Aniruddha, your answer is perfectly right. A is the right answer. See, I am telling you people, I have taken the question mixed kind. Some are the very straightforward formula based, and it will happen in the actual exam. Some are the very lengthy, some are the tricky one. Is it clear? So to practice all kind of question, it's very mandatory and it's very important required. Okay, right? So I will suggest you people solve this and tell me the answer. So guys, you might have studied that L, okay, diffusion. Let me give you brief. You might have studied in the EDC. L is equal to under root of d tau, where L is the diffusion length, d is the diffusion constant, tau is the carrier lifetime. You know, in any kind of the semiconductor specimen, there are majority carrier and minority carrier. And as the charge particle progress in the specimens, when there are both kind of polarity, the chances are there that recombination will occur and the charge particle may disappear. So the length up to which it can survive, we need some parameter, so that is the diffusion length. Okay, and it's defined L is equal to d tau, very important electronics device relation we have derived in the EDC. Is it clear? So you will be using this relation. He is asking for the diffusion length. L is equal to under root of dn and tau n. dn given to you and tau n given to you. Convert pico into normal, you will get the answer. So guys, answer will be as quoted by the Anirudh. This one, A is the answer. You can check it, you can take the screenshot for this. This is the answer for this. Is it clear? Check it please. Yes, right. Guys, you may like the session. If you people are doing the lot of good practice here, please like the session and just motivate us to do more. Okay, so can we go ahead? Fine. Next question you can see. Again, this question is again from the EDC. You can see the question is optical power incident on a photodiode is 3 microwatt and the photo current generated is 4 microampere. Then the responsivity of the photodiode is, guys, tell me what will be the responsivity of the photodiode. Tell me the answer please. What will be answer for this? Let me give you people one, yes, C is the perfect answer. Yes, Anirudh. See, many times there will be many questions which you can directly click from the unit. See, the unit is ampere per watt, milliampere per watt, and two quantities are given. One is the ampere quantity, one is the power quantity. So you may sometime click directly from the option and you can directly tell the answer. See, in photodiode, especially photodetector, the input is light and the output is your current. Is it clear? Right? So obviously he's saying the optical power incident, that is the input, is 3 microwatt and the photo current generated is 4 microampere. It means the output photo current we are getting 4 microampere. So it is basically indicative. Responsivity indicate how effective is your photodiode. Is it clear? Or you can say it is photo current generated per unit of the incident power, right? So you can see the solution will be C. So how I will be calculating the responsivity? I will directly calculate is equal to photo current generated divided by the power incident. It will be 4 by 3. So the answer will be straight away 1.33. So again, this is a bit of the question. Why I've taken this question? Because most of the students don't study these topics for the regular exam like GATE and all. They are very rarely asked there, but in ISRO, these kind of questions are asked a lot of time. Okay. So moving ahead, guys, next question. You can take the screenshot of this solution, and if you people need this PDF file, definitely I can give you it later after the session.
Okay, so in last previous paper of electronics, there was one question that was based on Verilog. Okay, so one question again you may expect related to basics of any Verilog or VSDL. Okay, so I hope most of the students can understand it and answer it. Okay, so Cool Bro is answering A. Verilog is a what? Programming language for hardware description or high level programming language for software development या डेटा विजुअलाइजेशन टूल या ऑपरेटिंग सिस्टम. सो वेरिलॉग क्या है? प्रोग्रामिंग लैंग्वेज है फॉर हार्डवेयर डिस्क्रिप्शन. ओके, एचडीएल. सो ए इज द राइट आंसर हियर, प्लीज रिमेंबर. सो एक क्वेश्चन ऐसा आने की पॉसिबिलिटी है, बिल्कुल बेसिक टाइप का. ओके, सो नाउ लेट अस गो टू द नेक्स्ट प्रॉब्लम. सो हियर ए इज द राइट आंसर, प्लीज रिमेंबर.
So again, guys, this question is again from the EDC, and I'm telling you again, this is very, very important question. The question is, a silicon solar cell has short circuit current of 100 milliampere and open circuit voltage of 0.7 volt. Under full illumination, the maximum power delivered to the load by the cell is 50 milliwatt. Then what is the fill factor? See, this is a question based on the photovoltaic cell or solar cell or PV module, photovoltaic module. So ultimately, if we ask how to measure the effectivity or efficiency of any photovoltaic module, for that we take one parameter into consideration, that is the fill factor, right? So option A is 0.321, B 0.714, C 0.921, D 0.521. Tell me the answer, please. Anirudh, answer is B. Other people, please comment down answer. Yes, Aniruddha, perfectly. Your answer is perfectly right. See, this question may be either asked in the other way. Sometime he may give you fill factor and ask you what will be the maximum power delivered to the load. The same question was asked in the BARC exam recently. They have asked what is the maximum power delivered to the load by the cell. They have given the fill factor, but here the question is a silicon solar cell has short circuit current 100 milliampere and open circuit voltage 0.7. Under full illumination, the maximum power delivered to the load by the cell is 50 milliwatt. What is the fill factor which will satisfy these all conditions? So to measure the effectivity, the efficiency of any PV module, we make the use of the parameter fill factor, and the answer B is correct, 0.714. So guys, remember this. The fill factor is defined as maximum power divided by product of the open circuit voltage and short circuit current. Right, Subi, the answer is B. So if you put on the value, you may end up getting 0.714. So guys, you may take the screenshot of this solution. I'm telling you again, if you need the PDF of this entire session or whatever document I've taken here, that you may access after asking in the comment section that you need this PDF. Okay, right? So I hope you all are done. Now moving ahead. Now question coming from the communication. The question is the capacity of the binary symmetric channel with crossover probability of 0.25 will be option A 0.094, option B 0.1887, option C 0.756, option D 1. Guys, come up and comment on this, please. Tell me. This is the question from communication. Tell me answer. Guys, tell me answer. What will be answer for this? Please put your answer on the comment section. Come up, please. So, whenever we talk about the information theory and coding, then we have the multiple kind of channel: noiseless channel, lossless channel, binary symmetric channel. They all have the channel capacity, and I've told you many times, you must remember what is the formula for their channel capacity. Not for all. If we are writing the ISRO exam, at least you must know what is the channel capacity formula for the binary symmetric channel. Lot of questions are usually asked in the ISRO exam, in the BARC exam, on the basis of the channel capacity. So guys, in binary symmetric channel, we have the two, symbol or two information, 1 and 0. It may be transmitted one as 1 and 1 may be transmitted at 0. So there are some distribution of the probability. There is a channel matrix for the probability. From there, we can calculate the channel capacity. I'm not going for the entire derivation, but for the exam, telling you people, remember the channel capacity formula of the binary symmetric channel. Okay. And I've told in the beginning, see, while solving the communication question, many times you will require the value of log 2. You will be requiring the value of log 3. See, if you know the value of log 2, you can write the value of 4 and 8 correspondingly, right? So at least remember the value of log 2 and log 3. So yes, Aniruddha, yes, Subi, yes, other people, tell me what will be answer for this question, right? So I am not able to see the answer for this question. Nobody is responding. Please come up. Yes, it may take some time to solve, right? So you can see the answer will be B, guys. The channel capacity of the binary symmetric channel is given like this way: 1 plus P log 2P plus 1 minus P log 2 1 minus P. So that's what I'm telling you people. Remember this formula. Simply put the value of P, which is 0.25. You will get the final answer 0.1887, right? So moving ahead toward the next question. Guys, this question is very important question. An ideal N channel MOSFET has the parameter W. Width is 15 micrometer. Mobility length is 1.5 micrometer. TOX, this is the thickness of the oxide layer, 300 angstrom. Threshold voltage 0.8. If the transistor is operating in the linear region means a very beginning part of the triode region, right? VDS is equal to 1.5 volt. Then the value of the transconductance is, he is asking transconductance value in into 10 raised to power minus 3 Siemens, right? Some constant is being given to you people. So the constant are these. These are the oxide layer, dielectric constant, and this is the permittivity of the free space, right? So option is A, B, C, D. Tell me the answer. What will be answer? Come up, please. Tell me the answer. So this type of question you may also expect, right? So I have told you people, if you don't remember the formula for anything else, then you know the transconductance Gm will be equal to how much? Del Id upon del Vgs. Is it clear? At constant Vds. So at least you know what is the drain current equation in the linear region. See, there are the multiple region. Triode region is there, saturation region there, cutoff region is there, right? So he is talking about the linear region. Linear region is the beginning part of the triode region for very small value of the VDS. Okay. So if you don't remember the exact formula, you remember the drain current, make a derivation of that with respect to gate to source voltage, and whatever resultant equation you are finding, put these all values there. See, I told you people, many of you might be thinking this is a very lengthy question, but I have told you many times there may be 2 to 4 questions which might be, having a very good calculation, and they are very easier, and they may give a passage for you people to give in the top rank in the written exam, because most of the people will skip those kind of question. If you have time, definitely go and attempt these kind of question. Guys, come up, tell me what will be answer. An ideal N channel MOSFET has the parameter mentioned here. Again, I'm repeating, the entire data is on your screen. Please tell what will be answer. Yes, Anirudh, Subi, tell me the answer. Please come up. Come up. Please tell me the answer. I believe if you have a good command of the MOSFET, you remember the drain current and voltage equation, then it will not take more than 1 minute. At max, if you are very slow in the calculation, 1 minute 15 seconds are more than enough for this question. Please tell me the answer for this. So guys, answer for this is A. So let me give you solution for this. So I have told you people, this is the drain current equation in the triode region. So this is the oxide layer capacitance. This is per unit area, epsilon EOX upon TOX. You might have remembered this formula. Everything was given. If you put this EOX here, you will end up getting this relation. W was given in the question, L was given in the question. So finally, you solve this, you will get this crux. And then I told you people how to calculate transconductance. This is the proper way to calculate the transconductance. You don't need to remember the formula. Is it clear? Make a differentiation of this with respect to VGS. Then you will end up getting this value. And what is the value of VDS given? Value of VDS given was 1.5. Simply put and make a multiplication, you will get this value. So guys, that's what I'm telling. I'm repeating again here. Most of the time students skip these kind of questions. They believe this question is very difficult or it may be lengthy, but you can see here clearly it's not lengthy question. The very first you need to write what is the current and voltage equation. Then you need to find these mu n, cox, w by l. Everything was given. Mu n was given, w was given, l was given, cox you were supposed to calculate. What is capacitance? Epsilon a upon d. Is it clear? But we are calculating here what? We are calculating here capacitance. You can see the unit for this is Faraday per centimeter square, means capacitance per unit area. Is it clear? So that's why I'm putting epsilon upon d. D is the thickness. What is the relative permeability? It's given 4 in the previous question. You can see the value given is 4. It's 4 and epsilon naught straight away given, right? So I'm just putting the value and solving this entire part. I'm getting this value. And later he's asking me to calculate the transconductance. I told you people to calculate the transconductance del ID upon del VGS at the fixed value of the VDS. The fixed value of the VDS was 1.5. You simply need to put the formula, nothing else. So telling honestly, it may not take more than 1 minute. Okay, अगर आप बहुत जल्दी कैलकुलेशन करते हो 1 मिनट में इसका आंसर आ जाएगा. तो आंसर इज 2.39 into 10 raised to minus 3. Is it clear? Moving next. Take this question, please. Take this question, please. Consider the sequence shown below. Again, it's from the signal system. Then the value of mod of x e raised to power minus j pi is. Option A is 8, option B 16, option C 17, option D 4. Tell me the answer. Guys, tell me the answer for this. Please come up. What will be answer for this? Come up, please. Yes, Anirudh, Subi. Guys, tell me what will be answer for this. It's a very good question from the signal system. Tell me what will be answer for this. Six sequences are given to you. At -3, the sequence value is 3. At -2, sequence value is -2. At -1, sequence value is 1. At 1, sequence value is 1. At 2, sequence value is 2. At 3, sequence value is 3. So what I can do, I can first write the sequence xn. Then you can see it's given x of e raised to power j omega. So I can find the dtft of that sequence, and you know that is x of e raised to power j omega. So by using the property of the time shifting in the discrete domain, I can write the dtft. Then instead of omega, I can put minus pi. So whatever value I will be getting in mod, that will be answer, right? So I hope you got the answer. Yes, answer A. A is the true answer. Yes, Hemant, A is the true answer. So what I told you people, I'm giving you again hint. First, I will be writing a discrete time domain sequence xn having the 6 sequence with value -3, -2, 1, 1, 2, 3. And then I will convert it into DTFT. You can see here the solution. It's clearly mentioned here. First, I made x of n sequence. So x of n sequence can be written sequence at -3 with value 3, sequence at -2 with value -2, sequence at -1 with value 1, sequence at 1 with value 1, sequence at 2 with value 2, sequence at 3 with value 3. I'm writing again 1 and -2 here and 3 here. So first I make this and then by taking the DTFT of this, I'm using the time shifting property, I will get this value. And later I can convert these by using the cos and sine relation with the complex exponential. I will end up getting these values, right? And since he is asking us this value, so what I will do, wherever omega, I will put minus pi there. So put omega is equal to minus pi here, minus pi here. Obviously, sine of this will be 0. So this will give me -6 and this will give me -2. The answer is -8, but he is asking in the magnitude mod. So what will be answer? Answer will be 8, which was the A option. So that's what I'm telling you people. He may frame question in multiple ways, right? So moving right for the next question. Again, it's a signal system question. Do it fast. The question given is, the signal x of n is equal to 0.5 raised to power n un is applied to a digital filter and it yields the output yn is equal to del n a del of n minus 1. If the impulse response of the filter is hn has a sample value of 2.5 at n is equal to 1, then what is the value of a? You need to calculate this value of a. Guys, do it fast. What will be value of this a? Tell me the answer. You have the option -2, -4, -3, -1. Tell me the answer, please. Go ahead, please. Tell me the answer. Please come up. Tell me the answer, please. Tell me the answer, guys. So I'm giving you people hint one. You can take a digital filter with impulse response h of n, and this is y of n, and this is x of n. Since y of n can be written as x of n convolution with h of n, this is the time domain. Making the frequency domain analysis, y of z is equal to h of z into x of z. Similarly, what I can do, h of z will be equal to yz upon x of z. This is just kind of instruction, right? Okay. And y of z you can calculate from here, and x of z you can calculate from here, right? He's saying that if the impulse response of the filter is hn, if I take the inverse z transform of h of z, obviously that will be equal to impulse response, that is h of n. And he's saying this h of n is having a sample value of 2.5 at n is equal to 1. Then what will be value of a? This will be the entire structure to solve this question. Guys, tell me what will be answer. Please come up. What will be answer? This kind of the hint you need to solve this question. Okay. Now you can see here solution I've taken here. The same thing what I discussed just now, x of n and y of n. Taking the z transform of x of n, this will be transformed for this. Similarly, taking the z transform for y of n, it will be for this. Similarly, what I need to do, hz I calculated like this way, and I told you people, if I make the hz expansion, it will be somewhat like this, and hz can be written as summation of n is equal to minus infinite to infinite h of n, and साथ में क्या आ जाएगा अभी z of minus n. If you compare, you see z raised to power minus 1, okay, so it means it will be n value 1. So this will be the sample value at n is equal to 1. So this is equal to 2.5. From here you can calculate the value of a, that will end up getting minus 3. So the answer will be minus 3 for this question. So guys, it might seem here a bit of complex. Honestly telling, it's a very straightforward question. Hn was supposed to be calculated, and you need to compare the value of Hn at n is equal to 1. That will come in term of a, and from there you can equate the value and calculate the value of a, which is coming minus 3. I hope this makes sense, right? Moving ahead with the next question. Yes, Ravi sir, आइए.
हेलो एवरीवन, हम लोग आपका नेक्स्ट क्वेश्चन देखेंगे. नेक्स्ट क्वेश्चन है, कह रहा है एट व्हाट टेम्परेचर अ फेरोमैग्नेटिक मटेरियल बिकम्स अ पैरामैग्नेटिक मटेरियल. आपका क्वेश्चन क्या है कि आपका किस टेम्परेचर पर फेरोमैग्नेटिक मटेरियल आपका बिकम्स पैरामैग्नेटिक मटेरियल. तो जिस टेम्परेचर पर आपका जो है मटेरियल का प्रॉपर्टीज आपका चेंज होता है, उस टेम्परेचर को हम लोग आपका क्यूरी टेम्परेचर कहते हैं. ठीक है, तो यहाँ पर आपका फेरोमैग्नेटिक मटेरियल आपका जो है बिकम्स पैरामैग्नेटिक मटेरियल जिस टेम्परेचर पर होगा वो आपका टेम्परेचर होगा क्यूरी टेम्परेचर. क्यूरी टेम्परेचर, ये आपका क्या है, क्यूरी टेम्परेचर. हमने कहा कि जिस टेम्परेचर पर मटेरियल आपका बिकम्स आप फेरोमैग्नेटिक टू पैरामैग्नेटिक, दैट टेम्परेचर इज कॉल्ड क्यूरी टेम्परेचर. ठीक है, आपका फुल ब्रो, आपका ये ऑप्शन आपका करेक्ट है. ठीक है, नेक्स्ट हम लोग आपका देखेंगे. नेक्स्ट क्वेश्चन है, नेक्स्ट क्वेश्चन है आपका, कह रहा है कि which one of the following material is considered as a non-magnetic material. नॉन मैग्नेटिक मटेरियल क्या होता है, वह मटेरियल जो आपका जो है मैग्नेटिक प्रॉपर्टीज को आपका शो न करे. ठीक है, तो आपसे कह रहा है कि कौन आपका जो है which one of the following material is considered as a non-magnetic material. तो आपका क्या होगा, इसका नॉन मैग्नेटिक मटेरियल आपका क्या होगा. तो यहाँ पर आपका जो है डायमैग्नेटिक मटेरियल जो है ये आपका क्या होगा, नॉन मैग्नेटिक मटेरियल. डायमैग्नेटिक आपका क्या होगा, नॉन मैग्नेटिक मटेरियल. ठीक है, नेक्स्ट क्वेश्चन हम लोग देखेंगे.
Okay, so guys, next question you have, it is basically from the microwave or radar. You can see the question asked is, in a radar the pulse repetition frequency is given by 1000 hertz, pulse width of 1 microsecond, and average transmitted power of 100 watt. The peak power of the radar is. See, I have told student many time in the classes that whatever important relations are there relating the pulse repetition frequency, pulse duration, peak power, average power, please remember those all relation. There are many time question being asked from that area. So guys, anyone among you, you know the answer for this, please put down there in the comment section. Come up please. What will be answer for this? This is a question from the radar engineering. Come up please. What will be answer for this? Yes, Anirudh, what will be answer for this? Yes, Subi, what will be answer for this? Come up please. See, you might have remembered one formula, average power is equal to peak power into duty cycle. So the answer you will be getting here, that is C answer. C answer is the correct answer, right? So remember this, they were asking you peak power. Peak power can be calculated average power divided by duty cycle, and duty cycle can be converted into duration of the pulse into pulse repetition frequency like this, and just put the value. you may end up getting the 100 kilowatt as a final answer. So in radar and microwave, if you haven't studied in well depth, but don't miss the standard formulas, there are 15 to 20 formulas from where only the question is being asked. Okay, moving at toward the next question. Guys, again, this is the analog question. Tell me the answer, please. Yeah, this is a very simple question. In the N channel E MOSFET, mu n CUX W by L is equal to this one, and the overdrive voltage required to operate above MOSFET in the saturation region is 4 volt. Then the drain current produced by the MOSFET will be. Tell me the answer, guys, please. What will be answer for this? Come up, please. Tell me the answer for this. Come up, please. What will be answer for this? Anirudh is saying C. Yes, C is the right answer straight away. C. Guys, you know, in saturation, drain current in the saturation is equal to mu n COX divided by 2 W by L inside of VGS minus VTN ka square. And guys, V overdrive voltage, it is nothing, it is VGS minus VTN. So ID set, it can be written as mu n COX divided by 2 W by L into V overdrive ka square. So you have all the parameters. This value is given 4. Is it clear? This is given here. Just put the value, you will end up getting the current answer will be 3.2 milliampere. So it must not take that much time. Please tell me the answer, right? So I hope you can see the solution. You can take the solution screenshot if you wish. If you wish to take the solution screenshot, you can take it from here. So that's why I have taken solution already for your references. So this will be the solution same which I discussed. He was asking to support the overdrive voltage of 4 volt in the saturation region, what amount of drain current is needed. So you can calculate like this way. Okay, moving toward the next question. Guys, this question is very important, and many times these kind of questions have been asked in the ISRO exam. Tell me the answer again from the EMFT. The current density at the surface of a thick metal plate is 100 ampere per meter square. The skin depth, if the current density at the depth of 0.01, it will be 0.01. If the skin depth at the if the current density at the depth of 0.01 meter is 28 ampere per meter square, tell me what will be skin depth. Come up, please. This is very important question from the ISRO exam point of view. Tell me the answer, please. So guys, this value is 0.01, not 0.01. It's 0.01 meter. Tell me the answer. You might have studied that electromagnetic waves, when propagate in the materials, it depends upon the material property. Up to what distance the wave is propagating or not. The same concept can be applied for the current in the thick conductor or thick material, thick medium, right? So you need to see up to what penetration that is flowing. The same question is being asked here. The current density at the surface of the thick metal is 100 ampere per meter square. The skin depth, if the current density at the depth of 0.01 meter is 28 ampere per meter square. Tell me, guys, what will be answer? Yes, Anirudh, this is a very good question. Come up. Come up. Guys, tell me what will be answer. Please come up. So the answer will be, guys, D. You can see whenever there is any question related to skin depth, I'm telling you one thing, be it in terms of the intensity of the electric field, be in terms of any intensity, you always use this relation. This will be that parameter or that variable as a function of x, and this will be the initial value at the surface or at the point where it's entering. Is it clear? So on the surface, the current density was given. But he is asking that what will be the skin depth. What is skin depth here? This delta is the skin depth here. You simply calculate here. So this delta can be calculated like this way. So this will be 7.87 mm. See, initially on the surface was given at some particular distance when x was 0.01. It was given 28. So I just calculated that value. Is it clear? You can see I calculated x upon delta is equal to 1.27. Since I calculated this at x is equal to 1.0.01, then I put the x value here and finally get the delta. Tell me, any confusion? Yes, Anirudh. Yes, cool bro. Hemant, clear or not? See, I have told you, na yaar, this will be the relation which you will be using whenever there is question related to skin depth. Is it clear? Since in the question it was given, you can see here, it was given in the question that at the surface it's 100. So at the surface initial value, you can see at the surface initial value J naught is 100 and J at x is equal to, you can see 0.01, it was equal to 28, right? So these two data we have. It means if at the surface it's J naught, if we are propagating this is 0.01 meter and here I am finding it 28, then what will be the skin depth? This is the question basically asked, right? Clear? So this entire data can be framed in the solution like this way. As I told here, you will be using this relation Jx, current density at any particular distance, will be equal to J naught e raised to power x by delta. Yes, Anirudh, I was getting 1.27, but inverse I couldn't do. Now, Anirudh, clear or still confusion? Anirudh, still clear or confusion? Tell me, please. Guys, clear or not? So this question is very important from the ISRO point of view. Anirudh, update. Is it clear now? Now going ahead, next question. Tyagi sir, please come for the mathematics.
Okay, so this is from matrix. So what is the answer? All of you write your answer in the chat box. Okay, so Anirudh is answering option number A. Okay, any other student who is present here? What will be the answer? Okay, so Anirudh, what mistake you have done here? We all know that A into A inverse. Okay, हमारे दिमाग में तुरंत आएगा कि A into A inverse जो प्रोडक्ट है दोनों का, this is equal to I. ये हम मान के चलते हैं ना, आइडेंटिटी. सो आइडेंटिटी ऑफ 3/3. सो आपने लिखा इसको तुरंत 100,010,001. ठीक है, and you calculated the trace as sum of these diagonal element, so you got answer 3, right? You got answer 3. But what mistake you have done? If you calculate the determinant of this matrix, tell me what is the determinant of this? If you calculate the determinant of this matrix, so what is coming? What is the determinant value, Anirudh? You can directly see R1 plus R2 is equal to R3. 2 plus 1, 3. 5 minus 1, 4. 3 plus 4, 7. So determinant is 0. And if determinant is 0, it means what? Matrix is singular. So matrix is not invertible. Okay? This matrix is not invertible. So A inverse does not exist. If A inverse does not exist, then how you can compute this product? This is not possible to compute A into A inverse because A inverse is not there, right? So what will be the answer now? Which option you should tick in exam? So D option you should tick in exam in this case because we cannot compute this. Okay, so D will be the right answer here. Don't give answer 3. You immediately came to your mind that A inverse is equal to I, but that is when determinant of A is not equal to 0. In that case, we write A into A inverse equal to I. Got it? So be careful in simple questions. Okay. Now we can move to the next question.
Again, guys, next question is on your screen, and this question is from the analog electronics. Please tell me what will be answer for this. Guys, again, next question is consider the amplifier circuit shown below, the value of the voltage gain. This is from the analog electronics. What will be answer for this? Do it fast, please. Come up, come up. So guys, we will go on the quick mode because it's taking a lot of time. Now see, you might have studied in the BJT. There are the two kind of the analysis. One is the DC analysis, one is the small signal analysis, right? Okay. So when you're talking about the biasing, then you go for the DC analysis. But when you're going to calculate the voltage gain and current gain, then you do the small signal analysis. Yes, Anirudh, your answer is correct. The answer will be 150. Okay. So answer will be 150. So guys, you can see here solution. What you will do while doing the small signal analysis, you will remove this DC sources, you will make ground for this one, and similarly you will short the capacitor, right, and replace this transistor with its RPI model or small signal model. I believe these all things are discussed in the theoretical steps. Okay, so whenever you have any question like to calculate the voltage gain, you simply do this. Otherwise, what I always suggest student, if you remember the formulas for these kind of configuration, it will be better. Many times students say सर ये तो रट्टा मारना हो यार, अगर कोई चीज आप क्रैम कर रहे हैं अपने फायदे के लिए जिसमें आपको बहुत कम टाइम में आंसर आ रहा है, it's better for you people, right? Okay, so now moving ahead with the solution, you can see I have given the solution for you people. You can see rest everything I connected as it is. I simply replace the transistor with its RPI model, and rest I remove the DC sources and simply connected the input here, and then applied the KVL equation around the loop, and I will end up getting output upon input is equal to 150. All the parameters and values are given here. Okay, so first ICIE, it was given biasing current is 0.5 milliampere. Beta is very large. You know, when beta is very large, we can approximate the collector current and emitter current, right? So from there you can calculate the transconductance. Transconductance is equal to GM is equal to IC upon VT, or we can approximate I upon VT. It is coming around 20 milliampere per volt. Is it clear? So now drawing the small signal analysis, then you can apply the KVL and all circuit analysis here. You will end up getting the voltage gain like this one. V out upon V in is equal to GM RC. RC was given in the question, that is 7.5 kilo ohm. GM already you calculated, right? That is turning out to be 150. This is I am solving right now. Otherwise, I have told student whosoever I'm teaching the analog electronics, I have told them the straightforward answer for this question, because always at the end of the discussion of entire BJT, I give them some sheet of the formulas where the standard configuration, voltage gain, current gain, input impedance, output impedance are summarized for their own easiness in the competitive exam like ISRO and all, right? Okay, so the answer will be 150, guys. Moving ahead for the next question, you can see next question is again from the EDC. N-type semiconductor sample is doped with 10 raised to power 15 donor atom per centimeter cube. The applied electric field is this one. If the current density produced inside the sample is this one, then the mobility of the electron inside the N-type specimen is. Guys, tell me what will be answer? What will be answer? Guys, repeat again. This is the EDC question. Very straightforward question. Let me give you one hint for you people. You might have remembered this point form of the Ohm's law. J is equal to sigma E. Similarly, conductivity is equal to N mu. Similarly, E. Is it clear? You might have remembered these all things, if I'm not wrong, right? So these only things you must be using somewhere here, right? So tell me, guys, what will be answer? Please come up, come up. What will be answer here? Please tell me. You can see electric field is given. It's given here. Similarly, this number, it's given here. Is it clear? Similarly, this current density, it's given here. So obviously, this one is given, this one is given. You can calculate the conductivity. If you know this factor, you know this value, and electronic charge is the standard value, you may calculate the mobility, right? I hope this can be done. Please do it. Please do it. Yes, Aniruddha and others will tell me the answer. See, D is the answer. Wait a minute, sorry. Guys, A is the answer. Answer is coming A. Aniruddha, please check. Some mistake is there. You can see the solution on your screen. Aniruddha, please check. You can see the solution on your screen. Any mistake there, please? Guys, check. A is the answer. See, what I told you people, ND was given, electric field was given, current density was given. First, I use this relation. From here, I will calculate the current density. And in current density, I know it is equal to NQ into mobility of the electron. So mobility of the electron can be written as current density divided by NQ into E. This value was given here. You can see here, this N number I put from here. Is it clear? Electronic charge I know, and this electric field is given here. And then solve, you may end up getting this value. Tell me. Okay, 375 is option D. Let me check once, it might be typing mistake. Yes, 375. D is the answer. Perfect. D is the answer. Right, right, Anirudh. So the answer for this is D, guys. This is the D. Now moving ahead, next question. Again, this is very important question from the ISRO point of view. Tell me answer for this. What will be answer for this? The excess charge in a certain medium decreases 1/3 of its initial value in 15 microsecond. If the conductivity of the medium is this one, then the dielectric constant for that medium is, these four are the option. See, you might have studied the concept of relaxation time constant in the EMFT. This question is related to that. See, when we talk about the network circuit theory or we talk about the circuit analysis, then our time constant is measured in term of the R value, in term of the L value, in term of the C value. Either it's RC for the RC circuit, it's L by R for the RL circuit. If I talk about the field theory, there if I put some charge on the inside the conductor or on the surface of the conductor, or if I put some charge inside the dielectric, what effect that charge will show. If I put some charge inside the conductor, whether it will stay there or it will vanish and distribute on the surface. If I put some charge inside the dielectric, it will be staying there for all the time, or it will distribute or spread somewhere else. That entire phenomena is somewhere related to the concept of relaxation time from the EMFT, and this question is framed from there, and that is defined in terms of the property of the medium. And in electromagnetic field theory, I always tell you people, the property of the medium are measured in terms of the permeability, in terms of the permittivity, in terms of its conductivity. Tell me the answer for this, guys. He is saying the excess charge in the certain medium decreases 1/3 of the initial value. I am taking initial value is equal to 50 microsecond. Is it clear? And what is happening? Qi upon 3, obviously 5 microsecond. It entire process is taking 15 microsecond. So he is asking, if the conductivity of the medium is this one, then the dielectric constant of the medium will be. Tell me the answer. This is the given information. Yes, Anirudh? People, what will be answer? Please tell me. You will be having one charge equation with its initial value and one decaying factor. It will be somewhat like this. This is some time and this is your initial charge, and it will be decaying somewhat like this one. Is it clear? Now, at what rate it's decaying, that is being defined by the material of the medium, which are epsilon, which are conductivity. So this is the question from the EMFT on the relaxation time concept. Tell me the answer for this. So guys, you can see here the answer for this will be A only. Is it clear? The answer is 1.54, which is A only. I have made a solution for you people. You can check it here. I told you people, this is the initial charge and this is the charge which is varying with the T, and this capital TR is the relaxation time. So it's given that Q is equal to Q naught by 3, and I am getting this value from here. By taking the natural log, I will get relaxation time in term of the epsilon R. See, relaxation time is defined as epsilon upon conductivity, and epsilon is epsilon naught multiplied by epsilon R upon sigma. This is known as the dielectric constant. This is known as the dielectric constant. और यही चीज आपको निकालना है. ये given a question में, ये given a question में. You can see, so you can follow this entire procedure. This is the relaxation time concept. Please follow and tell me the answer whether it's correct or not. So guys, this is again a very straight or very important equation which shows how the charge will be varying with the time for the different medium with having the different conductivity and different property, right? So moving ahead with the next question. Again, this is a signal system question. It's given here. Discrete time system S with impulse response is given like this one. If the system difference equation Hn minus this, then what will be the value of K? So guys, tell me what will be the value of K? Yes, please come up, tell me the value of K. Again repeating, any discrete LTI system with impulse response is given if the system difference equation is h of n minus k, h of n minus 1 is equal to del of n, then what will be the value of K? Do it fast please, tell me the answer. Do it fast, do it fast. Please tell me the answer. So guys, you know here h of n is given in term of this. If you know h of n, you can calculate h of n minus 1. That will be 1 by 3 n minus 1 u of n minus 1. And you know one relation, very important. I'm telling you two relation which will be very helpful here. U of n minus u of n minus 1, that is del of n. Similarly, f of n multiplied by del of n, multiplication property of impulse. These two property you will be using here in this question, right? So what will be answer? Yes, Anirudh, 0.33 is the right answer perfectly. Okay. So I'm telling you again, the solution is here. You can see what I did. I just calculated h of n minus 1. I told that will be 1 by 3 n minus 1 u of n minus 1. Again, del of n. Then I simply use the relation u of n minus of u of n minus 1 is equal to del of n. And that I put here and equate the equation. I get the k is equal to 1 by 3. I'm repeating, I'm using two functions here, u of n, two property minus u of n minus 1 is equal to del of n, and one is the multiplication property of impulse. One is the multiplication property of impulse, which says that whenever any impulse or sample is multiplied with any function, the answer will be the value of that function at n is equal to 0 multiplied by impulse. Is it clear? These two property I'm using while solving this question. Okay. So moving ahead, next question. Again, this is from the signal system question. X of n be a discrete time signal whose z transform is represented by x of z. Then the z transform of y of n is equal to this will be. Tell me the answer, please. Tell me the answer. What will be answer for this? X of n is a discrete time signal whose z transform is represented by x of z. Then the z transform for this will be. Tell me what will be answer, please, guys. Out of 4 option, do it fast. Come up, do it fast, please. बताइए भी क्या आंसर आएगा. कम अप प्लीज. So guys, can be written as 2 1 2 raised to power minus n x of n. This can be written, right? And it's given that x of n is pair with x of z, right? Fine. Now how to move ahead? Then what will be 2 of minus n x of n? Can we use some property? Yes, there are lots of property of z transform. Those property can be utilized, and I can calculate the value in term of x of z and then multiplying the factor with 2 itself. You can see in all the option. See, this is not option. This is not option. We have C option, D option, because here 2 is multiplied, 2 is multiplied. So tell me what will be answer for this. Do it fast. Answer will be C. How? You can check here. So as I told you people, x of n is transformed with x of z, y of n, it can be written like this. Again separating this, again using this property. This is a very important property you might have studied, right? Clear? So what I can write a? I can write 2 raised to power minus 1, and if I take 2 minus 1 above, it will become 2. So the answer will be 2x of z. Check it please. So this is the property of the z transform I'm using here. This is the property of the z transform I'm using here. Check it, nothing else. See guys, it is taking a lot of time. That's why I'm directly telling you the solution here, right? I just break down and make it in such a form that I can directly use the property. Yes, Anirudh, answer C is right. So moving ahead with the next question. Again, this is very good question. In fact, as per the question of the ISRO trend, a series resonant circuit has impedance of this one. The value of the capacitor for this circuit is, tell me guys, what will be this one? See, in resonant, either we have the series RLC, either we have the parallel RLC, right? So he's asking that a series resonant circuit has the impedance given by this one. Then what will be the value of capacitor? So tell me the answer. 4 values are here, A, B, C, D. 495.05 microfarad, 300, 100, 700. Tell me the answer, please. So guys, can I do one thing? Can I solve it and open and compare it with the series impedance of the RLC circuit? Tell me, can I do like this? So the answer will be A option. What I will be doing, you can see here, what I did, I simply open the given expression that is giving me this answer. And if I solve, I will end up getting this one. And you know, for series RLC circuit, the impedance is the addition of the impedance. R, SL, 1 by SC. Simply compare. This will give you 1 by SC. This will give you LS. And this will give you R value. So what you're getting here, 1 by C is equal to, you are getting how much? 2020. So C is equal to 1 upon 2020. Then you can from according to option, answer is coming 4.95 into 10 minus 4 Faraday. Since the options are in the microfaraday, so this will be the perfect option. The answer will be A only. So that's what I told you people. I have taken few questions which are a bit lengthy and which are calculative, which are very tricky and which are very straightforward. Okay, this kind of question you may expect. Moving ahead for the next question. Thank you, sir. Anna.
Okay, so this is a question from number system in digital. So you may get one question from number system also. Okay, so you are having two numbers in base 6. You have to add them and you have to tell the result in base 6 itself. Okay, दो नंबर्स हैं बेस 6 में और दोनों को ऐड करके जो रिजल्टेंट आएगा उसको बेस 6 में ही आपको बताना है व्हाट विल बी द आंसर. ओके, सो एनी स्टूडेंट हु वांट टू गिव द आंसर प्लीज राइट इन द चैट बॉक्स. In base 6 we are having two numbers. Anyone who has computed the answer, tell in the chat box. Okay, cool bro is getting 441. Very good. Anirudh, your answer. So you know, one option is there. One method you can do is you can convert both the numbers from base 6 into decimal, and you all know how to add two numbers in decimal. So you add them, you get a decimal equivalent. Okay, now you convert that decimal number into base 6. This is the one procedure. However, in our classes we teach to convert directly, to add two numbers in base R directly and to get the result in base R. Okay, so how we can do it here? We have a number in base 6. So it is 153. Okay, 244. We will write the two numbers like this. Okay, and now we will start adding from this right side. Now you know 3 plus 4. So 3 plus 4 is equal to 7, right? But in base 6 there is not a digit 6. Okay, base 6 में 7 तो कोई digit नहीं होता ना. There is no digit 7. Okay, so here our sum obtained is greater than the largest possible digit. So whenever sum obtained is greater than largest possible digit, then we subtract base from this sum. Okay, so we write sum minus base. So sum is 7 here, or minus base is 6, so equal to 1. So here we will write 1 and we will add a carry 1 to this left side. Okay, now we will again do the same procedure. So here 5 plus 1 plus 4, so 10. 10 is not a digit. Okay, so we will subtract the base 6. So 10 minus 6, 4. We will add a carry 1 here. Now 2 plus 1 is 4, and 4 is a digit in base 6, so we will write 4. So 441 is the right answer. Very good, Hemant. Very good, Anirudh. So this direct conversion is important. Okay, now we can go to the next problem. So what is the answer immediately? This is a 10-second or 5-second question. All of you in microprocessor, which is the right answer? All of you please tell me the answer. माइक्रोप्रोसेसर के इंटरप्ट के बारे में आपको इंफॉर्मेशन होना चाहिए थोड़ा. Which one is not a vector interrupt? So Anirudh, you are right. Cool bro is writing C. So you know we have vectored and non-vectored interrupt. Okay, so trap RSTs are the backed interrupt. INTR is the non-backed interrupt. Okay, so please remember INTR. This is non-backed. Okay, so B is the right answer here. Others are backed interrupt. केवल एक non-backed interrupt होता है INTR. So please remember this. Okay, it can save your time. Such question also come in exam. Now let us move to the next question.
So guys, there is one more question from the EMFT on your screen. This is also the probable question. The question is electric field intensity at a distance of 10 km from an antenna having a directive gain of 3 dB and radiating a total power of 30 kilowatt is. You have the four options. Tell me the answer, please. What will be answer for this? See, let me give you people hint here. You know, the average power is mentioned here that can be defined in term of the electric field by using the pointing vectors, that is E square upon twice of eta naught, where eta naught is the intrinsic impedance or space impedance, right? And similarly, you might have studied the radiation or power formula for the antenna with the directive gain in the EMFT. So if you combine or club these two relation, then from there all the parameters are given. The distance is also given, the directive gain is also given, and the radiating or total power is also given. You need to convert first directive gain into normal value because it's given in the dV. Then from there you can equate E square upon 2n is equal to the ratio of the radiated power in term of the directive gain. Then from there you can calculate the electric field value. Just do it, please. Tell me. Tell me, guys, what will be answer for this? So guys, the answer for this will be 0.189 volt per meter. So you can see what I told you just now. Directive gain was given to you people. This was in the dV. Convert it into the normal value. That will turn out to be this one. And this is basically the pointing vector relation, right? So you can see it is E square upon twice of eta naught. And from here, one relation you might have studied in the antenna relating the average power and radiated power with respect to the directive gain. And this directive gain you calculated here in the normal range. This range is given, distance is given to you. And guys, instead of this, you can use this value, and this is mentioned in the question. So the only variable here is E, nothing else, right? So I hope now you can solve what is the intrinsic impedance. Eta you might have studied is equal to 120 pi, or you can write out it some 377 or 380 ohm around. Okay, so in this entire relation you need to solve for the value of the electric field, and finally you will end up getting this value, right? This will be the answer for this antenna question. Now moving ahead, next you have this question. A N channel MOSFET is biased with VGS is equal to 2 volt, VDS is equal to 1 volt. The value of the threshold voltage for the MOS is 1.5 volt. Then MOSFET is operating in which region? Tell me, कौन से region में operate करेगा अभी? The options are active, saturation, cutoff. Tell me what will be the region? कहाँ पे operate करेगा? Let me give you option here. Option A is cutoff. Option B is saturation. And option C is a triode. Tell me the answer out of these. What will be the region of operation? Guys, tell me what will be the region of operation here. B, saturation. See, you might have studied that one is VGS. It must be greater than threshold voltage. If this is condition, then it will be in the on state, right? If VGS is less than VT, then it will be in the off state, or off state is also known as the cutoff mode. So you can see VGS is given 2 volt and threshold voltage is this one. So I can write VGS is equal to 2 volt, which is greater than 1.5 volt. It means it is not the mode of operation. This is not the mode of operation. And once it's sure that it's in the on, it can be in the triode, it can be in the saturation, right? So how to check that? I have told you people, VDS must be greater than equal to VGS minus VT. If this condition is satisfied, then it will be in the saturation. What is VGS? VGS is, I guess, 2. What is threshold voltage? Is 1.5. So what will we be getting? We will be getting here 0.5. What is VDS? VDS given 1. Yes, this relation is true. The answer will be saturation mode. You can see I have also put the solution down here in the section. Right, so the MOSFET is operating in the saturation mode. It is operating in the saturation mode. Fine. Now moving ahead, we have the next question for you people. Tell me the answer. This is also the very good question. Please tell me the answer. The question is, consider the diode circuit shown below. The diode in the circuit is a large high current silicon device whose reverse leakage current is reasonably independent of the voltage appearing on the diode. If V0 is equal to 1 volt at 20 degrees Celsius, then the value of output voltage at 40 degrees Celsius will be. Tell me the answer for this. This is a very good question. Tell me the answer for this. Tell me the answer for this, guys. Do it fast. What will be answer for this? See, yes, definitely there are few questions not in the very core computer organization. Microprocessor is enough. It will work for you, right? You don't need to go into the hardcore of the computer organization. So guys, for this question, you might have listened. I'm giving you one hint. That leakage current doubles doubles itself for every 10 degrees Celsius rise. Every 10 degrees Celsius rise. How many of you know this? And this is a very tricky question, right? And you also might have studied I naught at T2 is equal to I naught at T1 twice of delta T divided by 10. So obviously I naught at T2 is equal to I naught at T1 and twice of T2 minus T1 divided by 10. The same thing, if T2 minus T1 is 10, it doubles for every 10 degrees Celsius. The same question. Now, what the question is being asked, the question asked is, if this V out is 1 at 20, so then what will be V out at 40 degree? It means he's asking what variation will this V out take with the temperature variation. Option A 2 volt, option B 3 volt, option C 6 volt, option D 4 volt. So guys, can I calculate here? V naught will be equal to I naught upon how much? 1 mega ohm. Are we are right? And you know V naught is given 1. Where I'm doing this calculation? At 20 degrees Celsius. Right? What will be here? You know what I can calculate I naught here? You can see better. I will take you the solution. You can see here. What I calculated first, I naught 1. This is at 20 degrees Celsius. Fine. So this is 1 microampere. Perfect. And we know the reverse saturation current doubles itself for 10 degree rise. So this is the equation for that. And T2 minus T1 is 20 degrees Celsius. Since I want to calculate I naught 2, so I naught 2 will be equal to I naught 1 into 2, this one. So it will be 4 microampere. And guys, if I know I naught 2, or we can write I naught at 40 degrees Celsius, right? So I can calculate from here the voltage. What will be voltage? Voltage at 40 degrees Celsius will be equal to I naught at 40 degrees Celsius multiplied by 1 mega ohm. So what I'm getting, I naught 4 micro. So 4 micro into 1 mega, it will give me 4 volt, nothing else. So what will be answer? Answer will be 4 volt, and many students are giving the correct answer. So why I have taken this question intentionally, reason being, most of the time students don't click like such a way. Okay, see, you need to understand one thing. Now, yaar, if he's writing that V naught is equal to 1 at 20 degrees Celsius, means current is flowing like this. This is N, this is P. It means current is flowing from N to P. N to P only the reverse leakage current flow. It means this current is I naught. And I naught is leakage current. It is a temperature dependent. If this is a temperature dependent, obviously V naught will be the temperature dependent. That is why he is asking the value of V naught at the different temperature. So that will be different value. So the answer will be 4 volt D. Now moving toward the next question. Ravi sir, are you there?
नेक्स्ट क्वेश्चन है, ये आपका हम लोग देखेंगे। क्वेश्चन है, determine the magnetic susceptibility of a material if the field strength of a material is 0.8 into 10 to power 5। ये आपका टाइपो मिस्टेक है, इसको आप करेक्ट कर लीजिएगा। आपसे क्या कह रहा है कि determine magnetic susceptibility if the field strength of material is 0.8 into 10 to power 5। आपका यूनिट क्या होगा? एम्पियर पर मीटर। and the magnitude of magnetization is 0.97 into 10 to power 5 वेबर पर मीटर स्क्वायर। आपको निकालना क्या है? मैग्नेटिक सस्केप्टिबिलिटी। और हम लोग आपका जानते हैं मैग्नेटिक सस्केप्टिबिलिटी क्या होता है? मैग्नेटिक सस्केप्टिबिलिटी के इक्वल टू होता है आई बाई एच, जहां आई आपका क्या होता है? इंटेंसिटी ऑफ मैग्नेटाइजेशन। तो आपको जो है, और आई किसके इक्वल होता है? आई आपका ये, या आपका जो है मैग्नेटिक फील्ड आपका डेंसिटी आप कह सकते हैं। तो यहाँ पर क्वेश्चन में क्या दिया है? डिटरमिन द मैग्नेटिक सस्केप्टिबिलिटी ऑफ अ मटेरियल इफ द फील्ड स्ट्रेंथ ऑफ द मटेरियल इज आपका 0.8 इंटू 10 टू पावर 5, यानी H का वैल्यू आपको दिया है 0.8 इंटू 10 टू पावर 5 एंड द मैग्नीट्यूड ऑफ मैग्नेटाइजेशन, यानी आपका B का जो वैल्यू है वो आपका दिया हुआ है 0.97 इंटू 10 टू पावर 5। तो आपका क्या करेंगे? आप इस फॉर्मूला में पुट करिए, तो इंटेंसिटी ऑफ मैग्नेटाइजेशन आपका कितना है? 0.97 इंटू 10 टू पावर 5 अपॉन आपका H कितना है आपका? 0.8 इंटू 10 टू पावर 5। जब इसको आप सिंप्लीफाई करेंगे तो आपको वैल्यू जो है, जो भी आपका वैल्यू मिलेगा वो आपका क्या होगा? मैग्नेटिक सस्केप्टिबिलिटी होगा। आपका अनिरुद्ध आपका 1.21 ये आपका करेक्ट आंसर है। ठीक है, ये आपका करेक्ट आंसर है। ठीक है, नेक्स्ट हम लोग देखेंगे
So guys, next question is on your screen. For the RLC series circuit shown below, the damping ratio will be considered। R का वैल्यू दे रखा 1 किलो ओम, L का वैल्यू दे रखा है 10 मिली हेनरी, C का वैल्यू दे रखा 0.01 माइक्रोफैराडे। Tell me the answer for this. What will be the damping ratio for this circuit? Please come up. Comment please answer. A is the right answer. Yes, other people are there. Subi. Yes guys, what will be answer? So answer will be A. See, you know, second order systems have the oscillations, right? Okay, so they are asking the damping ratio zeta. So you might have studied in control system, there are 4 cases for the stable system. We studied overdamped, underdamped, critical and undamped, right? So those 4 analogy are being done here with the second order network or electrical system. So what you will do, you will first calculate the transfer function, then compare the characteristics equation. From there you may calculate the zeta value. So if you see the solution, I have taken the entire analysis. First I took the transfer function, then I compare this with the characteristics equation. Okay, this one. But you don't need to do that much. You simply remember directly the value. The zeta can be defined in terms of R, L and C with this relation. Is it clear? So for GATE exam, he may put any conceptual twist and turn, then you need to use your mind. But in the ISRO exam, many times he asks the straightforward question that if RLC is given, what will be the zeta value? So zeta value is coming 0.5. And he may ask one more question, the given electrical circuit is under what stage? So you know 0.5 is under damped. If zeta is between 0 and 1, it will be a under damped oscillation. Is it clear? So the answer for this will be, guys, 0.5, which is perfectly your A answer. Moving toward the next question. A stable multivibrator is designed using 555 timer IC. You can see here 555 timer IC is being used to design the stable multivibrator. A stable multivibrator जिसके दोनों स्टेट स्टेबल नहीं है, जो फ्री रनिंग ऑसिलेटर है, ऑसिलेट करता रहेगा हाई स्टेट से लो स्टेट, डिजिटल एनालॉग में प्लस वी सेट से माइनस वी सेट, राइट। आपका फ्री रनिंग करता रहेगा, आपको क्या देगा, स्केयर वेव देगा, ऑसिलेशन देगा। उसमें आपके पास क्या आएगा, ऑन पीरियड भी आएगा, ऑफ पीरियड भी आएगा। ऑन पीरियड ऑफ पीरियड को ऐड कर दोगे तो क्या बन जाएगा, टाइम पीरियड। टाइम पीरियड को रेसिप्रोकल कर दोगे तो क्या बन जाएगा, फ्रीक्वेंसी ऑफ ऑसिलेशन। तो वही क्वेश्चन यहाँ पे पूछा गया है कि 555 टाइमर को हम यूज कर रहे हैं, आई एम रिपीटिंग, 555 टाइमर को हम यूज कर रहे हैं, किसके लिए यूज कर रहे हैं, फ्रीक्वेंसी ऑफ ऑसिलेशन के लिए। तो इसका फ्रीक्वेंसी ऑफ ऑसिलेशन क्या होना चाहिए, आपको यहाँ पे आर ए, आर बी और आर सी का वैल्यू देना चाहिए था, वो यहाँ पे नहीं है, सो लेट्स स्किप इट। ओके, सो जस्ट रिमेंबर द फॉर्मूला। फ्रीक्वेंसी ऑफ ऑसिलेशन का फॉर्मूला ये होता है 555 टाइमर का, 1.45 डिवाइड बाय आर ए प्लस ट्वाइस ऑफ आर बी इंटू सी। Why I'm skipping? Because usually the RA, RB and C value must be provided here to you people in the question. So they are not being provided here. Apart from that, if you know RA value, अगर आप ये वैल्यू जानते हो, अगर आप ये वैल्यू जानते हो और आप ये वैल्यू जानते हो, उसके बाद मेयरली आपको ये क्वेश्चन सॉल्व करने के लिए सिंपल एक फॉर्मूला याद रखना है फ्रीक्वेंसी ऑफ ऑसिलेशन का फॉर 555 टाइमर। अगर आप स्टेबल मोड में यूज कर रहे हो, दैट विल बी दिस वन। Is it clear? Since the values in the question were missing, that is why I'm telling you directly the solution. So you can put any of the value given in the question, you will get your answer, right? Moving ahead with the next question. Tell me the answer for this, guys. Do it fast. What will be answer for this? This one is 20k, this one is 40k, this is 30k, this is 30k. Tell me the answer for this. Do it fast. Come up, come up. What will be answer, guys? बताइए भी क्या आंसर आएगा सभी, प्लीज पुट आंसर इन द कमेंट सेक्शन। द आंसर विल बी, आई गेस डी विल बी द आंसर, राइट? एनीवन देयर गेटिंग डी आंसर? सी, you can see this input is going on both, this is V1, it's going on both inverting and non-inverting. So under such case, what you do, you apply the superposition. Your output will be equal to V out plus and plus V out minus. Means first calculate the input at inverting and then see what output you are getting. What I'm writing, this is the output calculating by assuming input at the inverting, and this is the output calculated by assuming input at the non-inverting. You know, in network you might have studied, when you have the multiple sources in a circuit, then to calculate the response you can use the superposition for the linear IC, right? So you can see the solution I am made here. I'm not wasting the time here. First, what I did, when I consider the input at the inverting terminal, right, at the inverting terminal, the answer will be, you know, by applying the superposition theorem, when V1 at the non-inverting is short circuited, means we are considering the input at the inverting only. What will be that? That will be RF upon R1. RF upon R1 means minus 40 upon 20 into V1. We will get minus 2V1. Second case, I am assuming when V1 at the non-inverting is shorted. If V1 at the non-inverting is shorted, it means we are considering only at the non-inverting, right? So non-inverting, you will get this value. If you add both together, you will end up getting minus 2 V1 and this will be plus 1.5. Is it clear? I told you now you need to add these both voltage, this voltage and this voltage. The final voltage will be ultimately minus 0.5 V1, or you may write minus V1 by 2. So this is the answer. I hope you all understand the problem. See, I haven't done anything new. Input was being applied to both terminal. You can see here, this input was being applied to both terminal V1. First I considered it here only and grounded this one. So obviously output voltage then will be minus of 40 upon 20 into V1. So I will get minus 2v1. In second case, I consider this inverting at a ground and considering input at the non-inverting superposition. Then I will get 1 plus 40 upon 21 plus RF upon R1 multiplied by this voltage. Is it clear? So that all I calculated, and finally to give the overall voltage, I added both VO plus and VO minus, and finally I end up getting the answer minus V1 by 2, right? Now, next question is Ravi sir. Oh, no.
नेक्स्ट क्वेश्चन है, क्वेश्चन आपका है द रिलेटिव परमियाबिलिटी ऑफ पैरामैग्नेटिक मटेरियल इज, आपका क्या होगा इसका, द रिलेटिव परमियाबिलिटी ऑफ पैरामैग्नेटिक मटेरियल इज, आपका अगर आप रिलेटिव परमियाबिलिटी ऑफ पैरामैग्नेटिक मटेरियल का निकालेंगे तो ये आपका क्या होता है, ग्रेटर देन आपका 1 होता है, ये आपका क्या होता है, ग्रेटर देन आपका यूनिटी, ठीक है, आपका ग्रेटर देन क्या होगा, यूनिटी। नेक्स्ट क्वेश्चन हम लोग आपका देखेंगे,
Again guys, next question is basically from the communication. You can see here, this question is consider the circuit shown below. Okay, the input power spectral density is Sx omega, where Sx omega is given like this way. The output signal power is, these are the 4 options. Very good question. I suggest you all to solve this question, right? So you might be having one answer or one equation in your mind when Kitchener equation, that whenever input power spectral density is given to you, you can calculate the output power spectral density. So I may assume the output power spectral density is Sy omega, right? So can I treat this all as a single system? Why not? And calculate h of omega, right? I'm giving you hint. So Sy omega can be written as h of omega mod square Sx of omega. And he's asking the output signal power is, I'm giving you hint to you people, right? You need to solve it at your own. Now you will be believing, sir, this is a very big question. Will it be asked in the ISRO? Definitely these kind of question may be asked. I told you people in the beginning, there might be 4 to 5 challenging question and they will be very easy. And because of the lengthiness of the question, many times students skip them, right? So this is the hint basically. And you know, this is a power spectral density. He is asking for the output power, and output power, you know, is the area under the curve of the power spectral density. And I might have given many time relation, output power will be 1 upon 2 pi integration minus infinite Sy omega and d omega. I believe if you know this thing, you can solve the entire question. So what you need to do, you need to cascade this. First calculate the h of omega for this section, then calculate the h of omega for differentiation section, and then cascade them together. That will give you h of omega overall, right? Tell me the answer, guys. What will be answer for this? Tell me the answer for this. Do it fast. See guys, I'm giving you people the hint also. Tell me the answer fast, please. So we have less time. So answer is A, guys. Okay, so now tell me let me tell the solution. See what I told you people. See, there were 2 configuration, right? One was the differentiator. What you write for the differentiator? Are bhaiya, differentiator h of s is equal to s na, simply is equal to j omega, right? And second was the series combination of the R and C. For that I calculated h2 omega 1 upon 1 plus j. So both were in the cascadation. H of omega is equal to h1 omega h2 omega. That will be this one. What I told you, output power spectral density is equal to input power spectral density and mod of h omega square. So if I do the mod and square of this, then I will end up getting this one. And input power spectral density was given this way. And then finally he's asking us the output power. Right now I'm telling you the solution. That's why it may feel that it's a very lengthy. But I'm still telling, if you know the solution, it will not take more than 40 to 45 seconds. Right? So you can see here I'm repeating what I did. I first calculated the system function for this one. That become 1 upon 1 plus j omega. And then, you know, for differentiator, it is j omega. Both are cascaded. Multiply. I will get the entire overall h of omega. That's what I did here. You can see. Is it clear? And finally, I use the Van Kitchener relation. This one was the Van Kitchener relation. and from where I computed the output power, right? Again, what I'm doing here, guys, now you know the solution. This is the multiplication property of the impulse. Again, this is the multiplication property of the impulse. So when impulse at some point is multiplied with function, the answer will be the value of that function at the point where impulse is defined. Impulse is that omega is equal to -1. So put omega is equal to -1. It will be 1 by 2. Again, the same thing here, 1 by 2. And since integration is here, impulse will be there. Area under the curve of the impulse is 1. So the answer will be 1 by 2 pi inside 1 by 2 plus 1 by 2. It will be 1 by 2 pi. And you will end up getting 0.16 watt. Right now, I am teaching you. That is why it's taking a lot of time. Honestly telling, as a student, it will not take more than 40 seconds if you know the answer. Here I have used here two property. F of t, del of t will be equal to f of 0, del of t. Second thing, minus infinite to infinite, f of 0, del of t, dt. This will be equal to f of 0 multiplied by 1, because you take this out of the integration. Area under the curve of the impulse is 1. That's it, right? Okay. So moving toward the next question. Thank you, sir, please.
Okay, so one question from matrix algebra definitely may be there in mathematics section. So all of you must know how to compute eigenvalues of a matrix. So what is the answer here? Calculate eigenvalues of this matrix immediately and write your answer in the chat box. Okay. So Anirudh is getting D answer. Very good, very good. So you all know how to compute eigenvalues by solving the characteristic equation. So you can solve the equation 6 minus lambda to 11 minus 3 minus lambda equal to 0. Okay. So this product minus this product equal to 0. Quadratic equation will be there. Solve that. You will get the values of lambda. Those will be the eigenvalues. Or you can use another property, that is trace. You know, trace of a matrix is equal to sum of the eigenvalues. Okay. So here trace is 6 minus 3, 3. So eigenvalues का sum क्या होगा 3. ठीक है. Here we are not getting 3. So this is not the answer. Here also we are not getting 3. Not the answer. Okay. So only two options left. Now another property we have, product of eigenvalues is equal to determinant of the matrix. So what is the determinant? Minus 18 minus 22. So minus 40. So here we are getting minus 40 as the product. So D is the right answer. Okay.
So guys, next question is on the screen. A discrete sequence is given. The autocorrelation function at the origin is. Tell me the answer. Do it fast, please. So guys, a very good question. A discrete sequence is given, x of n, and the autocorrelation function at the origin for this sequence is asked. You know, we have the autocorrelation, cross correlation. Autocorrelation is basically a degree of similarities between the signal and its shift version, and cross correlation is similarity between the signal and another signal shift version, right? So he's asking the autocorrelation function at origin. Tell me the answer. 21. Absolutely true answer, right? Absolutely exact answer, right? Answer will be 21. Why 21? See, I have told you people, whenever autocorrelation being asked to you, you simply do x of n convolution with the reverse of the signal. This also I have taught in the signal system, right? And you know x of n, and you know you reverse the signal, then you might have studied the tabular convolution that I'm not going to discuss here, that you know how to make the arrow and add the values, right? So this is the solution, you can see. So that's what I told you people, right? Autocorrelation function can be written as a convolution of the function with its reverse version, and then finally you will get a tabular convolution like this way, and at origin value is coming 21. So answer will be 21. So next, moving ahead. Again, the H parameter matrix of the two-port network is given. Guys, tell me what will be the answer. If the network is said to be symmetrical, then the parameter x. You need to tell the value of x. Do it fast. Very simple question. Guys, tell me what will be value of this x. Do it fast. Come up, please. Guys, tell me what will be value of x. Do it fast. Do it fast. A, B, C, D. Arey bhaiya, you might have studied in the two-port network, be it Z parameter, be it transmission parameter, be it y parameter, be it h parameter, they have the symmetrical condition and reciprocal condition, right? He's asking that the two-port network, which is defined by the h parameter matrix, what is the value of x? We need to put here in this so that the corresponding two-port network is symmetrical, right? So the answer will be D, that is 0.56. You might have studied that for symmetrical two-port network, the condition in term of the h parameter is mod of h, if you remember, is equal to 1, or determinant of h is equal to 1. What is h? H11, H12, H21 and H22. Take a mod of this and equate equal to 1. You will end up getting this only, right? So x is equal to 0.56. Agreed or not? I hope you all are cleared with this, right? Can I move ahead? Come up, please. Can I move ahead? Now, next question is, guys, here. Again, this question is from the communication. Very straightforward question. A real and stationary process x of t is passed through the system. This is the given system, right? In the system, in one way it's going straight to the output, other way there is a delay of the 2 seconds. If the power spectral density of the process x of t, power spectral density for this is x of f, then what will be the power spectral density of the y of t? Tell me the option out of 4, please. Come up. What will be answer? So guys, can I write here y of t is equal to x of t plus x of t minus 2? How many of you agreed? Arey bhaiya, can I write like this? Yes or no? Come up, please. How many of you agreed? Can we write like this? Yes or no? Come up. So now he's asking the power spectral density for the output. So just now I told you people that there is a Van-Kitchener relation that Sy omega is equal to Sx omega and h of omega ka square, right? So don't you think if you are in position to calculate h of omega for this and take the mod and square, you simply multiply this with the input power spectral density, you will get the output power spectral density. Okay, he is giving in the f, you convert omega into f later on, right? So you can see the solution here. I have provided the solution also. The correct option is C. What I did, simply y of t is equal to x of t. There was a delay of 2 seconds. From there I calculated the system function and put s is equal to j omega and put omega is equal to 2 pi f, and I converted into mod of hf square. Just open it and you can convert it in term of the sine and cos, because option were given in the sine and cos, nothing else. Then you will end up getting the final solution. So the answer for that is C, guys. Okay, now moving ahead, you can take this file later. Again, tell me the answer for this. An amplitude modulated signal is given by s of t is equal to 20 plus 4 cos 2000 pi t plus 5 sin 5000 pi t cos of 2 pi f ct. The modulation index of the AM signal is, don't you think this is a multi-tone modulation? Okay, if this is a multi-tone modulation, then what will be the modulation index? Tell me the answer. Do it fast, please. What will be answer for this? Do it fast, please. Come up. Guys, tell me the modulation, please. Yes, Anirudh, Mr. Cool Bro, Nagarjun, tell me the answer, please. Come up, please, come up. So guys, what will be answer? You know, first you will convert it into a standard AM equation. And you know, yes, Mr. Cool Bro, answer will be mu is equal to under root of mu1 square plus mu2 square. That I understand. But what will be the ABCD option? What will be the exact value? So guys, I am providing you the solution for this multi-tone modulation. Answer will be C, 0.32. You know, first I need to convert the standard equation into the AM equation. If I compare it with the multi-tone standard AM equation, this will become mu1 and this will become the mu2 value. And you know, when we have the multi-tone modulation equation, then the overall modulation index will be given by this equation that will turn out to be 0.32. That's what I told you people in the beginning. The questions are of the all kind. They are straightforward, they are lengthy, they are a bit tricky also, right? So moving ahead. Tell me what will be answer for this. Do it fast. Come up. What will be answer for this? The trapezoidal pulse is applied to a differentiator. Is it clear? So this is going as an input to the differentiator. This is a differentiator. This is going as an input to the differentiator. we are getting the output signal y of t, which is d of xt upon dt, right? Then he's asking us what will be the energy of the y of t. He's asking the energy of the final signal which we obtained after the differentiating. Tell me the answer. Answer is 2 joule, 11 joule, 7 joule, 19 joule. Do it fast, please. Okay, guys, are you getting answer? See, let me brief it here. You know, this is a ramp signal. This is a constant. If I go for the differentiation, what I will get? Can I draw it here? Somewhere like this one, somewhere like this one. So this will be the, step. This will be the down step, right? This is the one of the shortcut method. Okay. So you need to calculate the energy of this signal. So you can go conventionally. You can calculate the, equation and then find the energy and all. What will be energy of the y? Energy of y will be equal to integration minus infinite to infinite mod of yt ka square dt. Agreed or not? Fine. So this slope is 1. This is again minus 1. So this is going from minus 5 to minus 4. This is going from 4 to 5. So if I take 1 will be here, 1 will be here. So under the integration, 1 plus 1 answer will be 2 joule. Is it clear? So this is the shortcut method. If you people want to go conventionally, you may follow like this one. But I will never allow this approach. Okay. Yes, Mr. Anil, right, true answer. 2 joule is the right answer. So guys, answers are there. So now go for this question. त्यागी सर आइए क्वेश्चन आपका number x plus 2 sin.
Okay, so all of you solve this problem immediately. This question, number is expressed in signed binary 2's complement form. Okay, so what is the decimal equivalent of this number? 2's complement representation से डेसिमल फॉर्म में कैसे हम रिकवर करते हैं इंटीजर्स को, ठीक है? सो ये आपको करना है. ओके, सो देखो सिंपल सा प्रोसीजर होता है टू रिकवर 10111111. ओके, जैसे ये टूज कंपोनेंट फॉर्म में लिखा हुआ नंबर है, राइट? एंड इसको आप कन्वर्ट करना चाहते हो वापस डेसिमल इंटीजर्स में. सो राइट 2 raised to the power 0, 2 raised to the power 1, 2, 3, 4, 5, 6, 7. पहले 2 की पावर्स में वेट असाइन कर दीजिए, राइट? नाउ जो एमएसबी है, दिस इज द एमएसबी. ओके, सो असाइन ए नेगेटिव वेट टू द एमएसबी. यहां पे बस आपको नेगेटिव में वेट लेना है एमएसबी का. नाउ कैलकुलेट द इक्विवेलेंट वैल्यू. सो 1 into this weight, so minus 128. Okay, 1 into this minus 128 plus 0 plus 1 into 2 raised to the power 5 is 32 plus 16 plus 8 plus 0 plus 2 plus 1. So this resultant will be the decimal equivalent. Okay, so you can simplify this. Now you can move to the next problem.
Yes, people, you can have the next question. The N channel E MOSFET, both are the N channel, are connected as shown below in the figure, right? Both the MOSFET are identical except that the channel width of T2 is twice of T1. See, both the MOSFET are identical. The only difference is the channel width of the T2 is twice that of the T1. This is the only difference. So what will be, they have asked, if the threshold voltage of T1 and T2 are 1.5, then the value of the output voltage will be, you need to calculate this value. What will be this value, guys? Fine. So these are the 4 options, A, B, C, D. It's mentioned assume all the non-ideal effects are neglected. Means you don't need to consider sub-threshold, you don't need to consider early effect, channel length modulation, nothing else here, right? Okay. So guys, tell me what will be answer. Do it fast, please. What will be answer? So people, answer for this will be 2.33. See, as you know, drain and gate are shorted. Drain and gate are shorted, right? Let me give you brief solution, then I will write the entire solution. So gate current is 0. This is 0 ampere because gate is insulated, right? So I always told you people, whenever gate and drain are shorted, so it will be always in the sat region. कौन से region में होता है भी? Sat region में. It means this is also in the sat region. This is also in the sat region. Means whatever current is here, the same current will go here. It means both are carrying the same current, right? Is it clear? So if I consider this as a T1, what it will be? It will be mu n cox w by L for 1 inside of VGS1 minus VT का square will be equal to mu n cox w by L for 2 inside of VGS2 minus VT का square. So guys, see, it's mentioned everything is identical. Everything is identical. Only the channel width of the T2 is twice of the T1. Okay, so that only we need to take into consideration. So now you can see I have taken a clear solution. I am repeating here a very neat and clean solution. Earlier, whatever I wrote, that was for a hint only. As the drain is connected to gate, both are in the saturation mode. ID1 will be equal to ID2. Whatever mu and Cux W by 2L you have, that I am interpreting as a constant, right? Since I told you people, K I am writing is equal to mu and Cox W by L. Now it's being told that all things are identical, but width of the second is double of the width of first. So obviously K2 will be equal to twice of K1. So instead of this one, what I will put here? I will put here 2K1 instead of K2. Is it clear or not? And VGS1 is 5 minus V0 and VGS2 is V0, because you can see the previous question and then put down the value, you will get the V out is equal to 2.33 volt. Okay, this is the only twist here. This one was only the twist here, nothing else. Rest everything you know, right? Moving on toward the next question. Sir,
ओके, सो सिंपल क्वेश्चन 5 सेकंड में आप कर सकते हो, टाइम बचेगा जो दूसरे क्वेश्चन में आप यूज कर सकते हो. ओके, सो व्हाट विल बी द आंसर? प्रिजर्व टाइम ऑफ स्टैटिक मेमोरीज डिपेंड अपॉन. स्टैटिक मेमोरी का प्रिजर्व टाइम किस पे डिपेंड करता है? याद रखना, इट डिपेंड्स अपॉन द पावर सप्लाई. ठीक है, पावर सप्लाई के ऊपर डिपेंड करता है. जब तक पावर सप्लाई है तब तक ये स्टोरेज करके रखता है, राइट? So C is the right answer here. Okay, please remember this important point. और DRAM के अंदर हमें जो डायनेमिक मेमोरीज होती हैं, we need periodic refreshing. ठीक है, उस पॉइंट को भी ऑलवेज आपको याद रखना है.
Guys, next question. We have considered the n most common gate circuit shown below. The transconductance is 2 ms millisiemens and R naught is equal to infinite, means there is no channel length modulation. You need to neglect that. What is the value of the voltage gain? See, the voltage gain will be again AV is equal to V out upon V in. For this PDF, I will share it in the comment section or I will put there in the description. You can access it from there. Okay, please like the session. Now see, what is the value of the voltage gain? I told you people many times, whenever they are asking you to calculate the voltage gain, then always go for the small signal model. Draw the small signal model, right? So the small signal model, you need to replace this MOSFET, E MOSFET with the small signal model. And the small signal model for the MOS is, this is your gate, this is your drain, and this will be a dependent current source, that is GM, VGS, that all being taught to you people in the classes. This is source, right? And this voltage is plus minus VGS. Simply while calculating the voltage gain, replace this circled area with this and just remove DC biasing, replace them with the ground and short the capacitor and finally solve the circuit. Okay, so the answer you will be getting, that will be 4.44. You can see here answer. What I did, I simply replaced the MOSFET with the small signal model. Rest everything is identical, and you can see clearly here. I can calculate here. So output is across the parallel combination of these two. That's why I wrote output voltage is equal to GM VGS minus GM VGS parallel combination of both. Since see, you are applying input here. This is VGS, G at the ground, S is going at the V input. That's why V input is equal to minus VGS. Put it here, you will get AV is equal to this one. That will turn out to be 4.44, nothing else, right? So moving ahead, next question, guys.
नेक्स्ट क्वेश्चन है आपका, क्वेश्चन है कि अ लीनियर वेरिएबल डिफरेंशियल ट्रांसफार्मर हैज, आपका दिया है फर्स्ट में कि वन प्राइमरी वाइंडिंग, सेकेंड आपका टू एग्जैक्टली सिमिलर सेकेंडरी वाइंडिंग, और थर्ड आपका है टोरॉइडल मैग्नेटिक कोर, टोरॉइडल मैग्नेटिक कोर। आपका जो है हम लोग जानते हैं कि एलवीडीटी आपका क्या करता है, लीनियर वेरिएबल डिफरेंशियल ट्रांसफार्मर एक आपका जो है इंडक्टिव आपका ट्रांसड्यूसर है। ये आपका जो है डी आपका नहीं होगा, क्योंकि आपका जो है इसमें अगर आप देखेंगे तो आपका एलवीडीटी में आपका क्या होता है, एक प्राइमरी वाइंडिंग होता है और दो सिमिलर सेकेंडरी वाइंडिंग होता है, और जो आपका कोर यूज होता है वो आपका सिलिंड्रिकल कोर होता है, ना कि आपका टोरॉइडल कोर होता है। ठीक है, तो आपका इसमें जो है कह रहा है कि लीनियर वेरिएबल डिफरेंशियल ट्रांसफार्मर हैज वन आपका प्राइमरी वाइंडिंग, वन प्राइमरी वाइंडिंग एंड आपका टू एग्जैक्टली सिमिलर सेकेंडरी वाइंडिंग होगा। लेकिन आपका कोर ऑफ आपका लीनियर वेरिएबल आपका डिफरेंशियल ट्रांसफार्मर जो होता है वो आपका सिलिंड्रिकल होता है। ठीक है, तो इसका आपका ऑप्शन क्या होगा, 1 और 2 आपका करेक्ट होगा, यानी कि ऑप्शन बी क्या होगा, इसका करेक्ट होगा। ठीक है, नेक्स्ट हम लोग आपका देखेंगे
So next guys, we have the few question from the communication. Okay, I'm taking the communication question more now. You can see this is the question. A BPSK signal with equiprobable bits is transmitted through an AWGN channel and received by a correlator receiver. The two-sided power spectral density of the channel is 1 nanowatt per hertz and the average bit energy transmitted is 10 microjoule. If there is no phase mismatch between the carrier signal used in the transmitter and receiver, then the probability of error of the system will be, see, he is giving the probability of error in term of he's asking the probability of error in term of the Q function, not the exact value. Yes, we will be definitely doing it for the mains exam. Okay, so we are asking your probability of error in term of the Q function. Guys, tell me, see, I have told you people, ASK, FSK, PSK, you need to remember their probability of error formula in term of the Q function, and you know that can be done in term of the distance between the signaling point from their constellation diagram, or you can remember the final value as well as. So tell me what will be answer for this. Do it fast, please. Come up, what will be answer for this? Please do it fast. So guys, answer for this will be C. Answer for this will be C. You can see answer here. I have taken here. Most of the you people might be knowing probability of error for the BPSK is Q function of under root of twice of bit energy upon eta naught, right? So this can be written as Q of under root of bit energy upon eta naught by 2. So it's given in the question that two side power spectral density means eta naught by 2 value given. You just substitute it there. That was in the nanowatt per hertz. That's why I converted nano into 10 to the minus 9. And EV bit energy was, I guess, 1 microjoule or 10 microjoule. I converted it here and put it here. You will end up getting Q under root of 10 raised to power 4. It will be Q 100. So the answer will be C, right? Moving ahead with the next question. Ayit, Ravi answer.
नेक्स्ट क्वेश्चन है आपका, मीगर इज एन इंस्ट्रूमेंट टू मेजर, आपका मीगर आपका क्या मेजर करता है, तो हम लोग आपका जानते हैं मीगर आपका क्या मेजर करता है, रेजिस्टेंस को, किसके आपका किस वैल्यू ऑफ रेजिस्टेंस को, तो हाई वैल्यू ऑफ रेजिस्टेंस को आपका मीगर इंस्ट्रूमेंट यूज किया जाता है मेजर करने के लिए। ठीक है, तो यहाँ पर आपका जो है आपसे कह रहा है मीगर इज एन इंस्ट्रूमेंट टू मेजर आपका इंसुलेशन रेजिस्टेंस। इंसुलेशन रेजिस्टेंस आपका क्या होता है, हाई वैल्यू ऑफ आपका रेजिस्टेंस होता है। ठीक है, अगर आपका रेजिस्टेंस का अगर आप लेंगे तो आपका अगर वैल्यू ऑफ रेजिस्टेंस आपका लेस देन 1 ओम होगा तो उसको हम लोग क्या कहते हैं, लो वैल्यू ऑफ रेजिस्टेंस। अगर वैल्यू ऑफ रेजिस्टेंस आपका 1 ओम से आपका जो है 1 ओम टू आपका 10 टू पावर 3 ओम तक आपका होगा तो उसको हम लोग क्या कहते हैं, मीडियम रेजिस्टेंस। और वैल्यू ऑफ रेजिस्टेंस एबव आपका 10 टू पावर 3 आपका ओम होगा तो इसको हम लोग आपका क्या कहते हैं, हाई वैल्यू ऑफ रेजिस्टेंस, और मीगर यूज टू मेजर आपका हाई वैल्यू ऑफ रेजिस्टेंस। ठीक है,
Guys, again, take the next question. It's again from the communication. Tell me the answer for this. At a given probability of error, the binary coherent FSK is inferior to binary coherent PSK by what amount? Tell me. It's a straightforward question. You can answer. All of you can answer. And you may expect this kind of question. Okay. So I told you people, ASK is there, FSK is there, PSK is there. See, PSK is superior to FSK by 3 dB. PSK is superior to ASK by 6 dB. FSK is superior to ASK by 3 dB. This series goes like this. I have told many shortcut like this. Okay. So what will be answer? At a given probability of error, binary coherent FSK is inferior to the binary coherent PSK by the 3 dB. He is asking in the dB. If you calculate in the normal, that will be 1 by 2. Okay. So solution here is, you can see. You know, this is the probability of error from the constellation diagram for BPSK. This is for the BFSK. If you find inside the Q function their relative comparison, you will find this is equal to 2, and ultimately if you convert it into dB, it will turn out to be 3 dB, right? So answer will be 3 dB. So you can remember that FSK is superior to PSK by 3 dB, and PSK is superior to ASK by 6 dB. ASK inferior to PSK by 6 dB, FSK inferior to PSK by 3 dB. Sequence goes like this, okay? Next, a continuous time function x of t is periodic with period t. So this is period t. Fine, very good question. The function is sampled uniformly with a sampling interval ts. In which of the following cases is the sample signal periodic? See, so the what will be answer? First answer, second, third, fourth. Always no. No. Answer will be this one. Why? Because I have told you people in the straight away class, whenever we sample any periodic signal, अगर टाइम डोमेन में पीरियोडिक है, अगर आप उसको सैंपल करके डिस्क्रीट बना रहे हो तो जरूरी नहीं हो पीरियोडिक होगा, वो पीरियोडिक भी हो सकता है, अपीरियोडिक भी हो सकता है। कंडीशन मैंने आपको बताया कि फंडामेंटल टाइम पीरियड और सैंपलिंग इंटरवल का रेशियो ये क्या होना चाहिए, रैशनल होना चाहिए। अगर ये कंडीशन सेटिस्फाइड होगी तो वो पीरियोडिक होगा। विच ऑप्शन इज सेटिस्फाइंग? ओनली बी ऑप्शन इज सेटिस्फाइंग दिस, तो आंसर विल बी बी, राइट? I hope you people are getting. So the answer is B. You can see here the explanation is written here. T upon Ts is rational. See, I have did a lot of detailed derivation for this. Whenever we sample any continuous periodic signal into discrete signal, the resulting discrete signal may be periodic, aperiodic. It depends upon T by Ts ratio. T is the fundamental time period of the continuous time domain signal. Ts is the sampling interval. If that ratio is rational, it will be periodic, else it will be aperiodic, right? Moving ahead with the next question. Okay. He's asking, estimate the value of ABC if I is defined as. See, he's saying the I is defined. This I is here. It's defined in term of I1 and V3. Okay. He's asking you to calculate the ABC value. So what will be answer? So answer for this will be, guys, again, see what you can do. You can make the source transformation and apply the loop. The loop equation will become somewhat like this one. And from there you can compare directly the ABC value, right? Moving ahead toward the next question. Again, this question is very good question from the communication. In digital communication system, the bit rate RB is equal to 8 kbps, right? The bandwidth of the channel is 10 kilohertz. The signal to noise ratio required for the error free transmission is, tell me the answer. Tell me the answer. Yes, cool bro, we can apply the source transformation. Very true. That's why I skipped that question. That was a very simple question. Okay. This is a communication question. In digital communication, you remove this. In digital communication, the bit rate is 80 kbps. The bandwidth of the channel is 10 kilohertz. The signal to noise ratio required for the error free transmission is, tell me the answer. Do it fast, please. What will be answer, guys? Come up. What will be answer? Do it fast. Yeah, you know that for error-free transmission, your bit rate must be less than equal to channel capacity, right? What is channel capacity? RB less than equal to B log of 2 into 1 plus SNR, Shannon-Fano relation. Is it clear? Everything is mentioned to you people, right? Signal to noise ratio is being asked here, and RB is given and B is given. Everything is mentioned. So I'm going for the solution. So your answer, correct answer is C. You can see that's what I told you people. For error-free transmission, your C must be less than equal to, sorry, R must be less than equal to C, or C must be greater than equal to R. So least condition, C is equal to R. So C, channel capacity by the Shannon-Fano relation is this one. From here, putting the channel capacity, which will be equal to the data rate, putting the bandwidth which mentioned there, and from here you can solve the mathematics and calculate the signal to noise ratio. You will end up getting 24.06 dB, right? So next, moving ahead, you can take this PDF. Everything is explained here in the proper detail.
नेक्स्ट क्वेश्चन हम लोग देखेंगे. नेक्स्ट क्वेश्चन है इन पीएमएमसी इंस्ट्रूमेंट स्वैम्पिंग रेजिस्टेंस इज एम्प्लॉयड टू. तो आपका जो है पीएमएमसी इंस्ट्रूमेंट में स्वैम्पिंग रेजिस्टेंस किस लिए यूज होता है? आपका जो है आपका अगर टेम्परेचर का वेरिएशन होगा तो आपका मेजरमेंट में आपका क्या होता है? एरर होता है. इन पीएमएमसी इंस्ट्रूमेंट आपका जो है इस एरर को जो है एलिमिनेट करने के लिए हम लोग क्या करते हैं? स्वैम्पिंग रेजिस्टेंस आपका यूज करते हैं इन सीरीज विद द आपका मीटर. इन सीरीज विद द मीटर यानी इन अ पीएमएमसी इंस्ट्रूमेंट स्वैम्पिंग रेजिस्टेंस इज एम्प्लॉयड टू कंपनसेट द एरर ड्यू टू टेम्परेचर वेरिएशंस. यानी आपका इसका ऑप्शन करेक्ट क्या होगा? ए ऑप्शन आपका करेक्ट होगा. ये आपका क्या होगा? करेक्ट ऑप्शन होगा. नेक्स्ट हम लोग आपका देखेंगे
Again, guys, next question is from the network. You can see the question is the value of V. This value of V is being asked here for the given circuit in volts. Answer is -4, -8, -12, -16. See, this is a very straightforward question. Take this as a P, take this as a Q. You can see P and Q are shorted. If this is shorted, then this resistance with loss is magnetism, its significance. If this lost its significance, then you can redraw the circuit. Okay, answer will be -4 volt. Do it fast, please. This is 30 ohm, 30 ohm, 10 volt, 10 ohm. V is the drop across 10 ohm with plus sign here, minus here. This is the 30 ohm. Just I told you people, yes, very good voltage division rule. Answer is -4. I'm going for the solution. As I told you people, I believe you all agreed you can redraw the circuit like this way. I believe you all agreed you can redraw the circuit like this way. Okay, if the circuit can be redrawn like this way, both are in the parallel, you can calculate the current flowing here, and current due to this 10 volt, that will be this value, and this current will be flowing here like this one. So V will be equal to -0.4 into 10. The answer will be -4. So the correct answer is -4. Moving ahead, guys. Again, what percent of the total energy in the signal is contained in the frequency band from here to here? This is very good question from the ISRO point of view. So tell me answer. See, I have told you people there is a possible energy relation which says energy of the y or signal is -infinite to infinite mod of y of t ka square dt in the time domain can be written as 1/2 pi integration -infinite to infinite mod of y omega ka square d omega. Now you can see this is the signal in the time domain. You can calculate total energy from here, and then he's saying if we calculate the energy in the frequency domain by keeping this integration range from -7 to 7, so whatever that energy is coming, what fraction that is of this total energy? Agreed or not? Fine. I hope the point is clear. So you can see here the solution for this is what I did. I calculated the total energy in the time domain. It becomes 0.5 watt. Then I calculated in the frequency domain for the given range. Then it was coming 0.455. Then what percentage? I calculated the percentage. Percentage is coming 91%. So the answer is B. B answer is correct, right? So guys, you can take this PDF. All questions are included here. Again, what is the inverse Fourier transform of x of t is equal to 5/2t? What will be answer for this? Come up, please. So you know 1/pi t is the Hilbert transform. Pair is minus j signum of omega. You can use this as a reference. Is it clear? So can I say 1/t इसका pair बन जाएगा minus j pi signum of omega. So what he's asking for 5/2 से multiply कर दो, इधर उधर 5/2 से multiply कर दो. Answer क्या बन जाएगा? Answer will be C option. True or not? Yes, Mr. Cool Bro. Answer is C. Very good. So now moving ahead, next again,
नेक्स्ट क्वेश्चन हम लोग देखेंगे. नेक्स्ट क्वेश्चन है द टाइप ऑफ डैम्पिंग यूज्ड फॉर मूविंग आयरन इंस्ट्रूमेंट इज. मूविंग आयरन इंस्ट्रूमेंट में आपका जो है कौन सा डैम्पिंग आपका यूज होता है? तो आपका मूविंग आयरन इंस्ट्रूमेंट में आपका एयर फ्रिक्शन डैम्पिंग यूज होता है। क्यों? क्योंकि आपका जो है मैग्नेटिक फील्ड इन मूविंग आयरन इंस्ट्रूमेंट क्या होता है, वीक होता है, और जहां आप जिस इंस्ट्रूमेंट में मैग्नेटिक फील्ड आपका वीक होगा उस केस में हम लोग एयर फ्रिक्शन डैम्पिंग का यूज करते हैं। ठीक है,
Okay, so this is from digital. Read the question. सक्सेसिव अप्रोक्सीमेशन टाइप एडीसी, ठीक है, उसमें जो डैक यूज करते हैं उसका वी रेफरेंस इज 4 वोल्ट, ठीक है। सो इफ वी कन्वर्ट ए वोल्टेज 1.75 वोल्ट्स इनटू डिजिटल, देन व्हाट विल बी द सीक्वेंस? ओके, क्या सीक्वेंस ऑब्जर्व होगा? क्वेश्चन को ध्यान से रीड करो, देन आई एम गोइंग टू एक्सप्लेन यू, एंड इफ यू कैन गेट द आंसर इमीडिएटली, यू राइट योर आंसर इन द चैट बॉक्स. You know, in successive approximation type ADC, we use DAC as the integral part. So what we are going to do, देखो DAC है इसके अंदर एक, ठीक है, और यहां पे हमारे पास होता है सक्सेसिव अप्रोक्सीमेशन रजिस्टर SAR, ठीक है। SAR का जो कंटेंट है दैट इज एज द इनपुट ऑफ द DAC, और DAC की आउटपुट जाती है कंपैरेटर में, यू ऑल नो दिस, ठीक है। इस कंपैरेटर में एक सिग्नल हम अप्लाई करते हैं, इनपुट सिग्नल VA, ठीक है, और ये कंट्रोल लॉजिक के थ्रू कनेक्ट होता है यहाँ पे विद द क्लॉक इनपुट ऑफ दिस रजिस्टर। ओके, सो रजिस्टर का कंटेंट चेंज होता है। नाउ 3 बिट की ये एडीसी है और 4 वोल्ट का वी रेफरेंस है यहाँ पे, 4 वोल्ट। सो व्हाट विल बी द स्टेप साइज के? स्टेप साइज के विल बी इक्वल टू व्हाट? वी रेफरेंस अपॉन 2 रेज़ टू द पावर 3, सो इक्वल टू 4/8 मतलब 0.5। सो इसमें जो स्टेप साइज है वो 0.5 है। सो यहाँ पे जो आउटपुट आएगा वी डैक, वो क्या रूल को फॉलो करेगा? वी डैक, सो वी डैक विल बी इक्वल टू के इंटू दिस स्टेप साइज के इंटू डेसिमल इक्विवेलेंट ऑफ द डिजिटल इनपुट। ओके, डिजिटल इनपुट इस रूल को फॉलो करेगा। नाउ इन दिस सक्सेसिव अप्रोक्सीमेशन कन्वर्टर वी नो दैट फर्स्ट ऑफ ऑल द फर्स्ट कंटेंट ऑफ दिस रजिस्टर इज मेड इन विच MSB इज सेट टू बी 1। ओके, सो सबसे पहले हम क्या करेंगे? 100, ये हम पहले MSB को 1 करेंगे, ठीक है। तो 100 विल बी द स्टार्टिंग स्टेट ऑफ दिस SAR। सो 100 यहाँ पे 3 ऑप्शंस में है, तो डी तो गलत हो गया आपका, यहीं से स्टार्ट करेंगे हम 100 से, राइट। नाउ 3 बिट की है तो 3 बिट की प्रोसेसिंग कंप्लीट करेंगे, ठीक है, 1 by 1। सबसे पहले हम फर्स्ट बिट की प्रोसेसिंग करते हैं, राइट। सो यहाँ पे हम या तो ऊपर की तरफ जाएंगे या नीचे की तरफ, 2 पॉसिबिलिटी है हमारे पास, राइट। सो 100 जब यहाँ पे है कंटेंट डैक के अंदर आएगा, तो डैक से जो आउटपुट आएगा वो क्या आएगा? 100 डेसिमल में होता है 4, सो 4 इंटू 0.5 कितना हुआ? 2। तो ये 2 मतलब जो डैक की आउटपुट है वो ज्यादा है और एनालॉग इनपुट हमारा 1.75 है, वो कम है, ठीक है, एनालॉग कम है। सो वी विल गो डाउनवर्ड, यहां से अगली स्टेट में नीचे की तरफ चलेंगे, ठीक है। और नीचे जाने में क्या करेंगे? ये जो 1 है इसको कर देंगे 0 और नेक्स्ट वाली स्टेट को 1 करेंगे और 0, ठीक है। सो नेक्स्ट स्टेट विल बी 0 1 0, राइट। नाउ अगेन वी विल कंप्यूट द डेसिमल इक्विवेलेंट ऑफ दिस, बिकॉज अब SAR का कंटेंट यहां पे जाएगा डैक में 0 1 0 और डैक से आउटपुट निकलेगा इस रूल के हिसाब से। सो 0 1 0 का मतलब होता है 2, सो 2 इंटू 0.5 कितना हुआ? 1, सो 1 वोल्ट। तो 1 वोल्ट तो यहाँ पे डैक का आउटपुट कम है इससे 1.75 वोल्ट से। सो अगर डैक के आउटपुट कम है देन वी विल गो अपवर्ड, ऊपर की तरफ चलेंगे, ठीक है। अब सेकंड बिट की प्रोसेसिंग होगी, यहाँ पे एक एक बिट की प्रोसेसिंग करते हुए आगे चलते हैं। सो जब ऊपर की तरफ मूव करना है सो इसको एज इट इज रखेंगे 1 और अगली को 1 कर देंगे। सो नेक्स्ट स्टेट विल बी 1 1। ओके, सो 100, उसके बाद 0 1 0 और 0 1 1, ठीक है। अब नेक्स्ट स्टेट क्या आएगा? फिर से हमारे पास 2 पॉसिबिलिटी होंगी यहाँ पे, 1 और 2, इस तरीके से। 0 1 1 का मतलब 3 और 3 को 0.5 से मल्टीप्लाई करेंगे 1.5। सो 1.5 अभी कम है 1.75 से, सो अभी भी कहां चलेंगे हम? ऊपर की तरफ, ठीक है। सो अगली बिट की प्रोसेसिंग करेंगे इसकी, तो इसको 1 रखेंगे, नेक्स्ट को 0 करेंगे, सो ये क्या रहेगा? 0 1 1, क्योंकि आगे कोई डिजिट नहीं है हमारे पास। सो 0 1 1, तो ये सीक्वेंस ऑब्जर्व होगा, ठीक है। 100, 010, 011 और 011 ये दोनों सेम रहेंगी। दिस विल बी द आउटपुट सीक्वेंस। नाउ लेट अस मूव टू द नेक्स्ट क्वेश्चन। सो डैक का ये कन्वर्जन का कंसेप्ट आपको पता होना चाहिए। नाउ व्हाट इज द आंसर ऑफ दिस क्वेश्चन? 5 सेकंड में आंसर कर सकते हो। रीड द क्वेश्चन केयर। कॉम्बिनेशन लॉजिक सर्किट्स आर द फंक्शंस ऑफ। सो क्या आंसर देंगे? कॉम्बिनेशन सर्किट किसके फंक्शंस होते हैं? प्रीसीडिंग इनपुट, करंट इनपुट, फ्यूचर इनपुट, या बोथ प्रीसीडिंग एंड करंट? सो इसका आंसर कोई भी लिख सकता है, करंट इनपुट। ओके, बी। जो आपके कॉम्बिनेशन सर्किट होते हैं वो करंट इनपुट पे डिपेंड करते हैं। सो बी विल बी द राइट आंसर। नाउ
now guys, we have the next question. Again, this is from the communication. The question says voice message signal which is band limited to 4 kilohertz, right? It's sampled at the rate of 50% higher than the Nyquist rate and quantized by 8-bit uniform quantizer. If the resultant bits are baseband modeled using raised cosine pulse with a roll of factor of 0.25, then the minimum baseband channel bandwidth required for the transmission of the data in kilohertz is, right? So ये क्वेश्चन कम्युनिकेशन का है। सी अगेन यहाँ पे बोला गया कि जो सैम्पलिंग रेट है दैट इज 50% हायर। सो व्हाट इज द सैम्पलिंग नाइक्विस्ट रेट? fs is equal to twice of fm, right? Yes, rb by 2 into 1 plus alpha cool bro, true answer, right? So how to calculate the rb will be number of bit multiplied by the sampling frequency, number of bit used per sample multiplied by the sample per second, that will be bits per second, right? So what I will do while solving this question, so answer will be for this, B. The B is your 60 kilohertz. What I told you people, the sampling frequency is 4 kilohertz. Sampling frequency, maximum frequency is 4 kilohertz. The sampling is twice of FM. ये मेरा FS है, right? But he is saying 50% higher. That is why I am taking 1.5. Otherwise, it will be 1 into 2 FM, right? But he's saying 50% higher. It means now the sampling is done at 1.5 multiplied by the Nyquist sampling rate. So what I will get? I will end up getting this value 12 kilohertz. So what is the bits per sample? There is a 8-bit quantizer, right? It means we are using 8-bit per sample. So what will be data rate or bit rate? Bits per second. The sampling rate unit is sample per second, right? It's sample per second, it's bit per sample. So sample cancel, bits per second is 96 kbps. So the minimum baseband channel bandwidth required is rb by 2 into 1 plus alpha, where alpha is the roll-off factor, and you can get the 60 kilohertz. This was the one of the communication question, right? Now we have the last question from the communication that was skipped by sir because he was solving his part. Now this one, again, this is a question. This question is, an idle AWGN channel has a bandwidth of 16 kilohertz and two-sided power spectral density eta naught by 2 is given this one, right? And this is B. If the average signal power of the binary data transmitted is, this is P, this is signal power, right? You can say signal. Then the maximum rate of the binary data that can be allowed to the channel without any error will be. Again, I told you people, your R data rate must be less than equal to C. So the maximum RB max can be equal to how much? It can be equal to C, which is B log of 2 into 1 plus S by N signal to noise ratio. I hope this makes sense, right? Okay. Get it clear? So now after solving this entire relation, I have made a tailored solution for you people. You can see the same thing I'm doing here. Fine. You can see the same thing I'm doing here. Spectral density was given. What is S by N? Signal power to noise power. Signal power was given. Noise power I need to calculate. What is the noise power? Noise power is spectral density multiplied by the bandwidth, right? So I calculate the noise power 80 microwatt. Then put it here, and RB max is equal to C is equal to B log of 2 into 1 plus Sn. I will end up getting the 80 kbps. I hope this makes sense, right? Shannon theorem. So guys, these were few of the questions. See, it take a lot of time. That's why I have framed the solution earlier for you people. I know when somebody is solving here 90 or 80 questions, it take a lot of time. Few questions of the analog electronics, they were weightage in this paper. So I skipped because I have taught many questions like this earlier. If you need this PPT or this PDF as a access with the detailed solution and question, you may put in the comment section that I need this PPT, or email ID you can share. We will forward this entire PDF for you people on your email ID. So the request is, if you need this PDF entire with solution, you can see detailed solution are being written here for each question. We will be sharing it with you for sure. If you put your email ID or anything in the comment section, through which our executive can send it back to you. Okay. So we wish you all the best for the ISRO exam. See, I try to take all type of question, lengthy, tricky, and straightforward. Hope it will be a good practice session for you. Thanks a lot. So that will be conveyed, Mr. Coolbro. No worries, right? All the best. Thank you.